ओह अरे यार चला गया क्या। चल चलते हैं, लाइव चलते हैं। हेलो 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 हेलो, हाय गाइस, गुड मॉर्निंग, वेलकम बैक। मोहम्मद नासिर भाई, देखकर चलाया करो भैया 10,000 यार। वो एक्चुअली लाइक आई ऑल्सो थॉट दैट इट वॉज माई वर्स्ट मिस्टेक एवर दैट आई वॉज ड्राइविंग लाइक दैट। लाइक now I got to know, no matter how good you are in driving, always your eyes should be at front, no matter like not right, left, right, no matter whosoever is going or anything whatsoever. If you want to do anything, just stop and then do anything. Well, that's what I realized. But yeah, Ritik, hi Ritik. Just quickly, firstly, third वाला question में 890 out of 912 test cases pass हुए थे. Maybe, yeah, that's the reason. Like third question was a bit edge case. I think the entire contest was a bit edge case related. So I think that edge cases figuring out is always a, you know, like always a tough job, like always a tough job, very tough job. So yeah, that's the reason I think that like this contest was actually tricky, to be frank, because it was very much edge case related. But yeah, still meanwhile, just quickly write down that how many questions you guys did and what all was the scenario. We'll quickly start off with question 1, question 2, question 3, question 4 and so on, right? Ritik, yo, third question, yeah, TON ton. I was able to solve only 2. No worries, Ritik. Although third one you should have tried and maybe reached to a solution. Maybe it doesn't pass. That's okay. But still, fourth question में ने हिला दिया आज. Yeah, the implementation is logic. Okay, logic is easy. Implementation is hands down so hard. Like it's the reason you will see that in fourth question many users tried, but only 1 or 10% of the users got submitted. So you know, solve 3 questions today. Today's contest was easy. Yeah, you can say question third is just that if you are able to figure out the edge cases, it's easy, else not. But cool. Still no worries. Now let's quickly jump on to our questions. Let's quickly jump on to our first question. It just says check if, yeah, and any point meanwhile if you have any doubts whatsoever, just comment down below. We'll be very happy to answer that, and I'll be looking at the screen for any of the questions which you guys have. And also if you guys are liking it, can you please smash the like baby. Check if the bitwise or has trailing zeros. Now everything, no worries if you cannot understand what the question says, but if trailing zeros means zeros in the end. Now it says that you are given an array of positive integers nums, and you have to check if it is possible to select 2 or more elements in the array such that the bitwise OR of the selected elements has at least 1 trailing zeros in the binary representation. Now it just says that we have to select 2 or more elements in the array such that its bitwise OR of 2 elements should have trailing zeros, at least 1 trailing zeros in the end. Like for example, they have given that 101 has no trailing zero because you can see it's a 1 in the end, and 100 has a trailing zero, which means it has a 0 in the end, and I want just at least 1 trailing zero, right? Now return true if it is possible to select 2 or more elements whose bitwise OR has trailing zeros, else return false. So I just have to choose 2 or more elements which can have the OR of them and have a trailing zero in the end. So as you know that for sure OR condition is just kind of an addition condition. Okay, if I have something as let's say 101, if I add something OR, so basically everything which has been there will actually get impacted on that location. That is how OR works. So one very brute force, as you can see constraints are pretty low, so one very brute force way is, and as you can see I can try 2 or more elements. So what I'll do is I'll try 2 elements itself. So I just try 2 elements if I have those 2 elements, and with those 2 elements I'll just try to figure out if their OR has trailing zeros or not. So I'll just do simple O of n square, kind of trying for all the possible pairs, and with that all the possible pairs I would be knowing that okay, if that specific thing has what OR it has, okay, I have got the OR value for that specific pair. I've got the OR value. Now I'll just check if that has a trailing zero or not. which is just nothing but, as you can see, the nums of I is also less than 100, so I can just imagine as 128. 128 is 2 raised to the power 7, so it is multiplied by 8, so it is O of n square into 8, which is a brute force approach, which will still work for you. Now if we just go back and look at the more optimized approach, or we can just go incrementally removing that O of n and then multiplied by 8, but I'll just go on to the most optimal approach which it can have, and it is just obvious that I'm doing an OR operation and I want a trailing 0. If I look back at the example which they have given us, so 101, it is a value of 5. What this 1 means, if we go back, and what this 1 means, if I just represent this number in the binary form, it means 0, 1, 2. 2 raised to the power 2 plus, which is 1 into 2 raised to the power 2 plus 0 into 2 raised to the power 1 plus 1 into 2 raised to the power 0, right? So you will see that all the others, all the here 1, because I'm just concerned about this last location. I'm just concerned about this specific last location. This is only and only impacted by this one, which is that the one right here. It is a 0 right here, it is a 1 right here. The corresponding value, as you can see, 2 raised to the power 0, it is a odd value, it is a even value, it is a even value. So you can see all the other values will always be even, it's just that only the first value is a odd. It's a odd, so it can only be odd. This thing, if I have a 1, then it will be a odd, as you can see. Else all the numbers are even. Even plus even is always a even, but even plus odd is actually a odd. So if I can get to know, if I can just imagine, okay, let's think in reverse. If I have a 1 in the end, which means the number would have been an odd number, because only when I have the 1 in the end, then only the number can be odd. Oh, so if the number is odd, which means I have 1 in the end. That is what I can infer from it. If the number is odd, which means I have 1 in the end. So I can just directly say one thing, that if the number is odd, I will have a 1 in the end, and that's how I can say, okay, I will have a 1 in the end. And that's what I don't want. I want only the one which has 0 in the end, which means it should, if I have a number which is even, so it will have 0 in the end. So I just want 2 even numbers in this entire input. If I have 2 even numbers in this entire input, which means 2 or more even numbers in this entire input, I can just OR them up and I will get the value which is actually even. So I can see I have 2 even numbers in here. I'll see I have 2 even numbers, or more than 2 even numbers in here. I see, okay, oh, I have no even number in here, so answer is false. Answer is 2, answer is 2. So I should have even number count more than or equal to 2, because it is select 2 or more elements, and that's how you can simply solve this in O of n operation, right? Any doubts whatsoever if you guys have? Bhai, how was fourth for you? Very hard. Like logic wise easy, but implementation wise, oof, lost. If we found 2 even numbers, then it's true, otherwise it's false. Yeah, true, that's true, done. And also please guys, keep on commenting your approaches, what you guys think should be the approach, so that we can actually like let's have a thing, okay, what you guys applied, what you should have applied in the contest and stuff, and how far were you able to think. Again, as I told, brute force will still work, but what approach still you applied, just let us know, that we have a quick communication between, okay, what's happening and what's not. Cool. Now we will just have a quick implementation of this. So it's as simple as that. And yeah, again, any other approaches which you have, just write down that below, that would be great. So I'll just have a variable called as count, which will actually keep track of the count of even numbers. Then I'll just iterate on all of my nums, and I'll just have a quick check if num mod 2, if that is equal to a 0, which means it's an even number, then I'll do a count plus, and I'll just have a quick check that if the count value is more than equal to 2, then I am good, simply return a true, else I can simply return a false. Again, this entire thing you can write this in the one line also, but no, who cares. So if you just quickly submit this, and it should work. Now we'll quickly go on to, I use Bitwise and to check for trailing 1. Trailing one, yeah, like although Bitwise and would be just a more overkill, but still, yeah, it's correct. Millie Aurora, Millie Aurora. Satvik, I was doing LC from an year 9 giving contest from the past 12 contests, and in 10 by 12 contests I was able to do only 2 questions. I'm unable to figure out what is wrong and how can I improve my count. Satvik, for the third question, for the question number 3 for today's contest, I'll ask you that what approach you took, how much you reached up till the contest. Then from that, because see, if you just say blankly I was not able to even able to think of anything in question number 3, I'll say that for sure we are missing many things. But at which point you were able to reach, and then from which point onwards you were not able to move forward, from that we can take off that, okay, how much we can do and how much we should have been done. Cool. Now let's quickly go on to question number 3 or question 2. So basically question 2 says that find the longest special substring that occurs thrice 1 and thrice 1 and this thrice 2 only have the difference in constraints, which is this is 5 into 10e5 and this is actually a constraint of 50. So we'll go on to this and firstly we'll just discuss the brute force approach, and then we'll discuss the optimum approach, and then we can copy the same code everywhere. We'll go on to the comments. And then, but again, for the ones who are not able to solve question number 3, just let me know one thing, that up till what point you are able to think of and apply, maybe as like Nasir spoke that he passed, like he wrote the code, but it reached to a point of 890 cases. So like this, just let me know that at what point you were able to reach, and then we will just figure out that was it good or not. Cool. And yeah, if you can please smash that like button, it would be super great. Cool. So if we go on to the question number 3, again we'll go on to comments, no worries. It says that find the longest special substring that occurs thrice or like twice or like thrice. Part 2. Now, it says that you are given a string S that consists of lowercase English letters. Okay, I have just a string S with lowercase English letters. That's okay, completely fine. A string is called special if it is made up of only a single character. For example, ABC is not a special string because it has 3 different characters, while DDD is a special string, ZZ is a special string, F is also a special string because it's made up of just 1 character. Now I have to return the length of the longest special substring of S, which occurs at least thrice. So this substring I have to see which should be special. Special means having the same characters, so it should have same characters. It should be a substring, which is okay, it should be a part of string, it should be a part of string, and it should be longest, which means having maximum length. Again, we'll just break out everything, and also it should occur thrice. Frequency of this substring should be greater than equal to 3, and I'm just saying at least thrice. So if I can even find 3, I'll be okay with it. Oh, my screen is not visible. So yeah, great, you guys didn't see and say anything, but cool. So what I'll do is, in this case, as I showed you, that same character, which means special is I should have same character in that specific part of string, and I want to have maximum length, and again the frequency of this substring should be 3 or more than 3. I'm concerned about at least. I'll just go back and yeah, like Anupam, we have just changed the screen, thank you so much for telling. Cool. So, and again, if it is not possible, then simply have a -1 now, and have a -1 if there is no special substring occurring at least 3 times, which means if these conditions are not satisfied, these conditions which I have mentioned here are not satisfied, then simply return a -1. Again, we know what is a substring like. So again, if we go back and look at the example first, so for very basic thing, we wanted substrings of length 3 having all the same characters. That's one thing, and also the length should be maximized. So if I just take this A, right, so you know one thing, that you just try to make, okay, bhaiya, what if I take this A's, I'll just take this A's, as one substring. So I should have four length substrings having all A's, and that should be having, like, it's just saying that with at least thrice longest special substrings. So substrings, like, not necessarily 4 A's, but it should have all these as same characters. All these are same characters. So one substring is this. Another substring, what I can find, I am thinking of the length 4, so it's not possible. So I'll just try for length 3. Okay, length 3, one substring I have found. Length 3, one substring I have found. Okay, still I wanted 3 substrings, which is not possible. Length 2, one, length 2, another substring, length 2, another substring. Oh yeah, I have found 3 substrings which I wanted. Thrice, right? Maximum length, again I tried from the very end, which is length 4, then length 3, then length 2, and then I reached to a length 2. Okay, it's a maximum length. Okay, length maximum has done. Same character I am always keeping track of. Substring, because I am taking a part of string, and also thrice occurring. So okay, the answer is 2. Now that is very basic normal stuff which we have seen in this. But if we go back and look at the constraints, okay, constraints I have not pasted, but if I just go back and show you the constraints was length is 5 into 1e, like 5 into for this example it is n is less than 1e5, 5 into 1e5 for this part 2, and n is less than equals to 50 for this part 1. So if I come back, so for this current example, if I have a substring of length n, I just want to figure out all such possible 3 length substrings. So what I can do is I can just go and try for all the 3 length substrings. Okay, 3 length substrings, 3 length substrings, 3 length substrings, 3 length substrings, and so on and so forth. Again, bhaiya, but length 3 nahi, count 3 should have been there. Length I have to maximize. So what I'll do is, bhaiya, I'll try on for all possible substrings. Again, that's a brute force approach. I'll try for all possible substrings, right? Then I will check. That can be done in O of n square, right? That can be done in O of n square. Then I will check if that substring has all same characters. Then it's a valid substring. Then it's a valid special substring. Now, valid special substring. I will keep, and again to check, it's just a O of n operation, right? You can also optimize this to have entire thing. It is entire thing in O of n square also. But yeah, let's keep it here only. And then when I have found out that it's a valid special substring, I can keep an unordered map saying that for this specific length of substring, which I have found above, as I know it's a special substring, so increase its count. How many such substrings are there? Increase its count. As soon as I found one, I'll increase a counter of 1. With this, I can keep track, and ultimately in the end, I can just get, okay, firstly I'll try for the maximum length, and then other length. As soon as, and whosoever has a count of more than equal to 3, I'll get that answer. So that is roughly a O of n cube, which will work for us, right? That is a brute force approach. And again, you can optimize this to O of n square also by clubbing these two conditions. That's again possible. Now, binary search worked for me. Yeah, again, binary search will work, but it can be a bit overkill. Still, it can be solved in less than that complexity. Now, like we had this entire thing. So one thing we got to know, that as we were trying on for these values, one thing is very obvious for us is that firstly we tried for, again, we wanted the maximum length. So you saw we tried for the biggest length, and then when it was not possible, then we went on to a smaller length, and then the smaller length. So when I say you have to try on for a length of, let's say, big length, small length, you are reducing your values sequentially, and as soon as you have got the valid maximum value, you will stop and return the answer. That's what you were doing. So one thing is, you were trying for maximum value, and then small, then small, then small, then small. So, and you were just trying for this, not possible, not, then it is possible, and for sure below that it's always possible. So it's kind of okay, it's a pattern where it's wrong, right. So what you can do instead is that you can just say one thing. Okay, bro, it's wrong, it's right. So I can simply apply a binary search on this. I can simply apply a binary search on this and say one thing that I'll try on for some x length of the substring. If this is okay, I'll try for a higher length. If this is not okay, I'll try for a lower length. That's what a binary search works. So now if I say you have to try for x length of substrings, what you will do, okay, let's say I just put in the characters of a string like this, right? And I'll go and ask you, your x length is 4. So you'll just simply go and try one thing, okay, length of 4. This all should have same characters, right? Okay, and again, this all should have same characters, and such substrings should have been count of more than 3. So I'll go and try for this length of 4. Now it is just a sliding window. Okay, next is this character. So okay, next is this character. So simply add the next character count, reduce the previous character count for this length of x. X is 4 here, and then again go on, slide your window again, and then keep on going. And when I say keep on going, I just mean that add your next character, remove your previous character. And simply you just have to maintain one thing, that your this all should have same characters. Now bhaiya, how will I maintain? You just have 26 characters, right? So you can maintain for that 26 characters that, okay, what is the count, what is the frequency of those 26 characters. So you can have a frequency array saying size is 26. So I will just maintain the frequency and we'll keep on updating this frequency. And if this frequency count of this 26 characters has only one character having the frequency, which means here you will see the frequency. Let's say here it is A, B, B and C. So you will see here the frequency of A will be 4, right? As soon as B will enter, so frequency of A will become 3, frequency of B will become 1. So I'm saying if the frequency of if I have only one character as a frequency, I can just say increase my count. If I have a B, as let's say here the B would have become 1, here it would have become 3. Okay, don't increase your count because I want only one character in the entire substring. Right now I can see because of my frequency I have 2 characters. Okay, again keep on moving. Here you will see as it keep on moving, your B count will increase, your A count will decrease, which means it will become 2. Again, I have 2 characters as I can see with my frequency, so I will not increase my count. Now I'll just keep on going. As soon as I encounter the count to be more than equal to 3, I can simply return a true. So for this condition, to check if the x length of substring is valid, I can simply go and do a sliding window. With this you will see that the lengths which is possible is nothing but the length of this entire thing, the multiple lengths which are possible. So log n factor for the length, trying on for this. Let's say you took this x length, you will try for log n lengths, but if you took this x length, then you will try for the entire array which is sliding window, which is O of n, but you will also keep track of this frequency. It is n into 26. Again you can optimize this part, but I'll just say it is n into 26. So your complexity will actually be n into 26 into log n, which will again, okay, it's okay, it will still work. You can again optimize that to O of n into log n. That's other optimization which you can have by simply keeping track of only the ones having frequency as like having the count of frequency as just 1. But again, that's okay. Can we still optimize it? Yes, we can. How? If we go back and look, again, if you have followed us, so we had reached to conclusion from O of n cube, we can go to O of n square, then from O of n square, we can go to O of n into 26 into log n, and then we can also go to O of n into log n by simply using a binary search itself up till here at this point. Now, can we again optimize it? Maybe not. Do you see one thing? What is the only thing which we want or need? If I go and ask you, if I just give you this part, this part, I'll ask you, bro, you have all the A's here. Can you let me know how many substrings of maximum length? And I'm just saying, okay, having same characters, I have already given you. Let's say I have already given you having the same characters, right? You know that the string which you will get only will have the same characters, as you can see here. It will have only the same characters. Now just let me know that what's the maximum length of substring which will have a count of 3. Just let me know that. It's as simple as that. If you know that you have all the same characters, so the condition right here will not be required. The condition right here will also not be required, right? The condition right here. Now I just have to like verify that I should have 3 substrings. So I'll just say one thing. Okay, one substring will actually be ending at last. Let's say if the length is n, I just put dot dot dot, length is n. One of these substring, and again make sure that all the characters are same. It's a example, it's all the A's, right? One of the substrings will actually end at the super end. Other substring will end at this point, right? Other substring, let me change the color. Other substring will end at this point, right? So with this, I will have a pink, red, and green as 3 substrings from this string of all the same characters, right? Now if I ask you, bro, how many such substrings? How basically I ask you, bro, what is the maximum length of this substring which you can have? I'll ask you, bro, what is the maximum length of this substring which you can have? So you will say, bhaiya, I can see that if I am ending here, so my green will end here, my red can also end here, my red can also end here, and my pink can also end here. Oh sorry, pink is very big, so my pink can also end here. These are substrings. But bhaiya, I wanted the length of the longest special substrings which occur at least thrice. So length is same, it should occur thrice. So bhaiya, what I can do is I can just say that if I just put my a again here, so I can bhaiya just say one thing, that my this part will end here, my pink part will end here, right? So you saw that you had a length n. Again, this length n is unknown to you, but you had a length n, and you can easily, you have to maximize the length. After maximizing the length, you got something like this, right? Now I'll put the exact same thing for this string to actually know what should be the value of the length what should be the maximum longest length of this substring that it occurs at least thrice. Again, longest length, which means all these 3 should have that same length only. So I'll just, again, for the folks who are not able to solve it, just let me know that at what point, up till what point, let's say O of n cube, O of n square, O of n in 26 log n, at what point you are actually able to stop or actually able to think of. Now if I again go back, I had this a, right? So I can just say one thing, that this green portion is this, the red portion is this, the pink portion is this, right? So you easily saw one thing, that I had n equal to 4, right? You saw n equal to 4 characters. My answer, which means the length, longest length, is 2, because 1, 2, and starting from n minus 2, like, which means like n minus 2 is the remaining length. So I'll just say n minus 2 is the actual length of one of the substrings, which is the green one, n minus 2. So that's the reason answer would have been n minus 2. For answer would have been n minus 2, considering I have all the same characters in my entire string. Okay, but bhaiya, I can still have different characters. How to handle that part? Yeah, that is true. Which means if you take an arbitrary example as A, B, B, C, D, okay, C, D, and E, okay, D. Now I ask you that can't we just bifurcate? I know, okay, its entire length is n. Can't we just bifurcate this? And for sure, if I can get all the same characters, I can very easily get to know that for this entire same characters, what can be the count, which is nothing but the length of this entire thing, n minus 2, right? Minus 2. So why can't I do one thing? I can just bifurcate this entire thing by simply using 2 pointers, or simply modify, like going on sequentially, and bifurcate that to this group, because I ultimately know one thing for sure, is I'm only concerned about the same characters. So I just bifurcated the same characters out, right? And ultimately I'm not concerned about the characters itself. I just want to concern about the count, which means the length of them. So I know its length is 4, its length is 2, its length is 1, its length is 5. Now you'll ask, Bhaiya, so what shall be the count? Like with the above example which you showed, if I take Ds, so I can have a D, right? I can have a D, right? Bhaiya, that is true. I can also have a A. Oh, that's something new, because if you would have taken only D's and you wanted 3 substrings, so you would have taken, okay, bhaiya, D1 here, D here, and D here. So answer would have been 5 minus 3, which is actually, sorry, 5 minus 2 is actually 3. So length is actually, you can also see, if I take only D's, it will be 3 as a maximum length. But now you saw one thing, bhaiya, oh, if I take a length of 4 for D, length of 4 of D, because I can take length of 4 of D, and length of 4 of A. So that is the reason. This is the edge case which you have to handle, that, oh, I will do one thing, I will have a length n, I'll grab the count of all these same characters. I have grabbed the count 4, 2, 1, 5, right? I'm just only concerned about three different lengths, right? I'm just concerned about 3. As you can see, I'm just concerned about at least 3. I should have at least 3 substrings, right? So I'm only concerned about 3 top lengths, which can actually infer and get me the answer. Again, not required that all 3 lengths will be used, but three top lengths would be required. So let me just write another length, let's say E, and E, and then I'll just make a group, and then other top length is actually a 3. So I'm just only concerned about the 5, 3, and 4 as the 3 lengths which can impact my answer. Now, bhaiya, why these 3 lengths will impact your answer? I'll give a simple case, that if in this example my A would have been 1 more, right? So my A count would have been 5, my D count was 5, my E count, let's say, would also have been 5. So I have got 3 substrings of 5 lengths having all the same characters. So answer would have been 5. That is the reason, that is the only reason I want top 3 maximum lengths. Now, bhaiya, but in this case we saw that the answer was 4. The answer was 4. How? Because you saw that you took this length, and you took this length. That's a case for us. So firstly, I have this entire length of n. I have got all the substring, like all the same characters. I have got them at the count of them. Okay, what is the count of them? Which means the length of them, of the same characters. When I have got them, I'm only concerned about the top 3 ones. Now write down the condition. Let's say you have these top 3 counts. Again, visualize this. Let's name it as L1, let's name it as L2, let's name it as L3. Write down what should be the condition, that what should be my maximum answer. Again, if you have just got the top 3 lengths, just write down below what should be the maximum length. Quickly write down that thing below. And that's the reason, like, thinking of these cases are the prime thing in this question, and thus it was actually hard. Again, I'll recommend, if you would have been solved it, binary search was the easiest way to solve it. You don't have to think of cases, but as I can see with the 4th question, the problem setter had one thing in mind, that you should be solving it with cases. So because 4th question is entirely based on cases, so quickly write down below that what should be the cases. Simple. Meanwhile, again, write down, pause it, I write down. Meanwhile, I'll tell that if L1 and L2 and L3 all should have been there, and if all are equal, then my answer would have been L1, right? Now, if I say you, bhaiya, L1 and L2 are equal, right? L1 and L2 are equal, but L1, or basically L1 or L2 is actually more than L3, which means L1 and L2 are equal, but L3 is less. And again, for sure, L1 is the highest, L2 is the next lowest, L3 is the next lowest. If this would have been the case, then I saw exactly one thing, that I can easily say, okay, I can easily make this condition. I will have L1, let's say I will have D, 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 right? Same lengths. I will have A, 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 same lengths. Then I will have L3, let's say it is EE. So I know one thing, that I can simply grab the length of 3 from here, length of 3 from here, and I know the length is same, which means L1 and L2 length are same, so I can always grab the length of 3 from here. So my answer would have been L2 or L1, any lengths minus 1, L2 minus 1, or you can also say as L1 or L1 minus 1, same method. Now what can be the other case in this? Simply other case is that anyway, okay, no matter what, if I have 3 lengths, if I had these 3 lengths, so you saw one thing, I had these 3 lengths. No matter what I have for this specific L2 or L2 minus 1, if I have these 3 lengths, this is a, let's say, again, if this length is more, L1 is more than L2, L1 is more than L2, then I can just do one thing. I know one thing, that L1 is more than L2, so I will have a D, 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 5 Ds, and let's say here it is A, 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 A. So one obvious thing is that I can grab this D, I can grab this D, I can grab this entire L2. So the answer will be, if bhaiya, but what if the answer L2 would have been 3? Yeah, I'll grab 3, then here I'll grab 3, here also I'll grab a 3. So here the answer would actually become a L2. L2 will be the answer. Simple as that. Now, oh bhaiya, okay, here I have said that I have L1 and L2. That is the other condition which I found. Bhaiya, what if I have only L1, as in like L2 and L3, as you saw that you had a AAA only, that no, for sure no L2 and no L3. Then simply the answer, as we saw above also, it is answer is equals to L1 minus 2, which is this exact same stuff which we saw. Exact same stuff, where it is gone. Yeah, which is n minus 2. And that's how with these cases itself you can simply get your answer solved. Again, these cases make things actually a bit tricky for you, but we can just club all these cases and say that what I will do is I will figure out my L1, L2 and L3. By default you can just figure out. Again, for the contest, I'll highly recommend that you should have taken the binary search approach. Binary search approach just says one thing: try on for some random length x, and try for this length. When I say try on as in do a simple sliding window maintaining the frequency of the character, and if the frequency of only one character is non-zero, then I will increase my count. And if this count is more than equal to 3, then I'll simply return a true for this specific x length. This would have been the most optimal way to solve in the contest. But in the interview, again, this is a good question because it has 4 or 5 follow-ups. So it is a very good question to be asked in an interview. In an interview, ultimately you will have to land onto a O of n solution. You will have to land but you will have to figure out these 3 smallest element. Again, to get this count, I can simply do a line, like simply I can just go through the entire array and keep on maintaining this count. You can do it simply by using a 2 pointers also, but you can simply go through this entire string to get this count. Now when you have get this count, all the counts, you want the top 3 counts. Is just although to get from this array of counts, which is the entire array of counts, you have to grab the top 3 counts. One very obvious way is you simply sort this entire thing up, which is one obvious way. Else, one other non-obvious way is, if I just ask you grab the 2 elements, which is the largest and the second largest element, then you do one thing. Okay, you assign the largest element to the first value, and then you assign to the, like, as you have also remembered, if I have 2 values, a new incoming value comes, how you do, see, it's as simple as that. If you have, let's say if one obvious way from this entire array of numbers to get the 3 smallest element is sort it down and get the number. Other better way to get it in O of n time is, because sorting takes O of n log n. Other better way is, you have these three elements, right? You can just, as soon as the fourth element comes in, you will ask if that fourth element, if it is, let's say it is L1, it is L2, it is L3. You assign the starting three elements. I'll just say L1 is the maximum of all three elements. L2 is the maximum of remaining two elements. It is all three elements. L2 is maximum of remaining two elements, and L3 is the last element. L3 is the last element. So with this, I have grabbed from the top, from the let's say if I just build the array of count, it is the array of count for you. I've built the array of count. Now array of count is, let's say, like this. So from the top three, from the starting three elements, I have grabbed the L1, L2 and L3, corresponding L1, L2 and L3. It is L1, L2 and L3. Now the fourth element, when it will come in, I will have to keep on modifying my L1, L2 and L3. It is just these three simple cases. If your L4, which means the next element which is coming in, let's name it as A of I, right? A of I. If this A of I is actually less than L3, then do nothing. If this A of I is less than L2, then actually modify your L3 with A of I. If your A of I is less than L1 and basically more than L2, then simply do one thing, that assign A of I to this value and L2 to L3. What if A of I is more than L1? Then assign A of I to L1, L1 to L2 and L2 to L3. With these simple cases, you can actually compute or get your L1, L2 and L3 in O of n time. But still, it is again some multiple cases which you can do, but it will still take a bit cases, and already we have more cases. So in the code itself, while showing you, I will simply sort it down. To actually get the top three values. But the more optimal approach to tell the interviewer in the interview is using this technique, right? With which you can grab the top three elements. Now coming on back to these four cases which we figured out, right? It can be just simply boiled down to a simple thing, that one very obvious thing is, if I have my L1 and L2 as same, right? And for sure L3 was there and was not there, and L3 was having a smaller value. Maybe if L3 was not even there itself, no worry. Like L3 was there or not there, no worries, and having a smaller value. Then I would have simply done one thing, that I would have given the answer as L2 or L1 minus 1. L1 minus 1. That would have been the answer. And again, I have asked you guys to comment down the approaches, like the conditions. No one did, no worries. Like a few guys did, but it says you only have to check for the length of the longer substrings. Solution. Yeah, that's true. Anatomically. Yep. Yeah, that if we have a few more solutions which are recommended, we also go on to that. But it's just that we, again, as I showed you, like nothing as such is necessary. We are just incrementally going on. Binary search is, again, the most obvious thing which I thought of is binary search, so it's the reason I just told that. But still, it can be solved in other ways also. Cool. If we still go and comment down the approaches which you guys thought of. So now it's simple as that. If L1 is equals to L2, then we can simply return the answer as L1 minus 1. In this case, when my actual L1 is more than L2, then the answer was L2. If I had only L1, the answer was L1. So if I just club these two conditions and say that because by default I can assign my L2 value as a 0 value, right? So L1 is more than L2, or I'll simply say L1. I just simply say one thing, that answer is equals to maximum of either my L1 minus 2 or my this value which is L2. I can also write the same thing as just combine this condition. This condition I have combined right here, that I have L1 and L2. and if all of these are same, which means if all of these are same for us, then if I have L1, okay, if all of these are same, then this will also consider in this condition itself, because if L1, L2 and L3 are same, so even if I say I have L1, then also I will just say that I can assign L2. L2 is actually equal to L1 itself, because L1, L2 and L3 all are same. So with these two conditions itself, you can simply get your answer done, and that's how you can simply get it solved. Cool. We'll quickly go on to the options which you guys suggested, and then we'll just simply code this up. Now, and again, meanwhile, if you guys are liking it, can we please smash the like baby? That would be super great. Cool. I use Bitwise and to check for the trailing one. Yeah. Same approach. 2, 3 O of n में किया या O of n log n में. Vivek, yeah. Again, that can be simpler than O of n time 2, 3. If two even numbers are there, it will result in having a 0 at the end. That's true, Joss. I ran 2 for loops and or 1 I and j and mod with 2. That's also like Ritik, that's a brute force approach. I wrote a brute force approach looking at it in the Python just to be fast. Yeah. In contest, the brute force approach is the best approach which you should try. Cool. By second and third O of n में किया है वो n log n में O of n bro. Although right now just so that to have L3, L2 and L1 to like not mingle in that, we can try to go into the simple approach that just simply doing a sort, but again that can be easily taken care of by just mentioning that whosoever is the maximum value out of all of them. By this you can simply get this solved again. Cool. 784 cases passed for Q3. भैया Leetcode tab है. My search worked for me. Yeah, please explain fourth. Yeah, we'll go on to that soon, Rudra. N-2, that's true. But yeah, I was able to think of the hash map approach with set to track if the given substring is special or not in the third question, but unable to implement it. Kumar, the hash map approach with the set to keep track if the given substring, I'll say hash map to keep the count would be good, but to keep the track of the substring itself for hash map would be a bit hefty for us for time complexity. I use sliding window and linear search rather than binary search, which is O of n into 2. N into 2. It's n square or n into 2? N into 2. I used sliding window and linear search. Sliding window and linear search. Yeah. Sliding window and linear search. Yeah, sliding window and linear search can again be used. I'll say it's more of that you will also have to maintain the count of that sliding window, which means sliding window and linear search. Satvik, and it's O of n into 2, or if it's O of n square. If it's n square, then okay, yeah, it will work. But if O of n into 2, I don't think the sliding window linear search will work for O of n into 2. 3 solved. That's great, Lil. Can we solve this using a binary search? Yep. We need the same. We need a same substring of same length 3 times, or could we have a different substrings but with the same length 3 times? O of n square. Yeah. So see, as you can see that it just says a special substring. A string is called special if it is made up of only a single character, right? I want longest special substring of s, right? I want longest special substring of s which occurs at least thrice. So it should be longest special substring. Longest special substring is a substring which has all the same characters. That's it. If no special substring occurs at least thrice, so a special substring is corresponding to that special substring itself. If that makes sense. Cool. Cool. Like cool, sorry, not cool. Now. Okay. Cool. Cool. Just a second. Yeah, that's true. We should have all the same characters itself, because it just says that longest, that specific substring, that special substring itself should be of that same length. So what we will have to do is that we will have to just a bit modification in this portion, that we have different lengths, but all these different lengths should be of same substring. Should be of same substring. Which means that if I have a AAA, EE, AA, DA, DDD, AAA, DA, AA. So I grabbed all the A's, all the A's, all the A's, all the A's, and all the A's. That's what we plot, and from that we need to have all the other special substrings. That's a great thing which Jagrit told, that I also didn't figure out, that we need to have all of them. As you can see, a string is a special string if it is made up of only a single characters, and that the length of the longest special substring of S, that specific length we have to return of that specific longest special substring, and that special substring itself should occur thrice, right? It cannot be any substring which can occur thrice. That is one thing which we had to make sure, which I actually missed. But again, expression will still remain same. It's just that for that specific character, I will keep track of all of my counts in one of the variables. Like I can say I'll keep track of a character to a vector of int, which means vector of int will keep track of that specific character, all the counts, what all are there, and then I'll just get, okay, for that specific character A, the count, which means the group count. Here, as you can see, the group count was 4, 2, 1, 5, 3. I'll just push that in my vector. Now when my vector for that, I'll push that in my map, and my map is for that specific character to the count groups. When I have all of that, I'll simply now iterate on that specific character, get all top 3 counts, and then apply the same approach. Here, that I'll say if my L1 and L2 are same, then simply return my L1 minus 1. Else you can simply go and return a L1 minus 2 comma L1 minus 2 comma L2. Again, considering that my L1 should be more than my L2, or my L1 should be there, so that would be the condition for me. And with this, you can simply get your answer. It's just that one thing which you have to make sure in this also, if your L1 is of length 1, L2 is of length 0, right? So we will still not be having 3 substrings, right? So which means I should say that my L1 plus L2 plus L3 should be more than equal to 3, which ultimately means that my L1 plus L2 should be more than equal to 3 itself. Or bhaiya, what if my L1 is 1, L2 is 1, L3 is 1, then also it's valid. So I should say that my L1 plus L2 plus L3 should be greater than equal to my 3. If that is the case, I can simply go and try this out. So it is AND condition with this. And if we just say, okay, with this condition, because L1 is the maximum value, so it will always be there. So that is not required for me now. And L1 is more than L2, that is by default, which I will keep track of. Which is by default, I'll keep, as you can see, by default, I'm keeping track of L1 is maximum value, which is more than L2. So this is also valid. So I can just only check this condition. That will be more than sufficient to get me the answer. Cool. Again, any doubts? Thank you so much, Jagrit, for this. Else it would have been wrong. Now Android do not need binary search. You only have to check the length of the longest substring -1, that's true, longest substring -2, that's true, and just 3 linear searches or no solution. Yeah, that's that's true. We can, it's just that how we implement that, that can also work. Satvik, yeah, O of n square, yeah, that is a bit more cool. If you have no more doubts, then we can simply go and implement this solution. So as I spoke, that we will have an unordered map, unordered DERED map. Now unordered map is saying for that specific character, give me the count of groups, like count of size of groups. So for that specific character, let's say the map. Now this map is from this character, let's say A, from the character A to the count of size of groups. So as I told you, 4, 3, 2, like 4, 3, 2, 4, 3, 5, 2, 2, 1, and so on and so forth. So it is from character to actually vector, or basically vector of count of group size. And this group again, and this group is actually and this group should be of all same characters. Now when this portion is done, now you will simply can go on to the entire array and get the count. So I can just say that count is 0. Now I can simply go on to all the characters in my entire string. Now I just have to make sure that I have to get the group count, right? So let's keep the track of the last character. So I can just say that character last character is actually nothing but my s of 0, and so I'll just check, okay, if my current character is equal to my last character, then simply increase the count, right? Else one obvious thing is, else if my character is not there, then simply in your map for that specific character, which is the last character, just push back the current group count which you have got, and the group count is this specific count. And again reset your count back to 1, because you have considered, because this current character, because here you are pushing the last character, but you are on this current character, so you are actually on this current character, so you just push this count as 1, because you are also, because in the next loop iteration you will be on the next character, so current character you should count here itself, and then put your last character for the next character as this C. And anything else which you need to do, or we are good? Yeah, as you saw that we are just pushing in the last, so for the last character group count it will be missed. So what we should do is, we should say that last character just push back the count itself, now anything else which you need to do for this? Now we have got the map with us, we have got the count, we will just go and iterate on all the characters itself now. So I'll just say that for auto pair in my map, now I'll just say character C is nothing but p dot first, and and also vector of int of group counts, let's say group count, or basically group size is nothing but my p dot second. As you can see, p dot second, I should put in by address because of no point to copy it again and again, because as you can see I just wanted for A the group size is actually, let's say x, y, z, and so on and so forth. Now this group size, I need to grab the top 3 elements. Again, you can also go on to these conditions which I showed you to grab the top 3 elements, this entire thing which I showed you, but it will be a bit long. So what I can do is I can simply sort this group size, sort the group size dot begin and group size dot end and dot end and I want it to be in the greater fashion, so as to grab the top 3 elements. So I'll just say greater int, and then that's it. Now it is sorted. I'll just grab the, as I showed you, I'll just have L1, I will have L2, I will have L3. So just saying that L1 should be always greater than equal to L2, should be always greater than equal to L3. Now when this portion is done, I'll just check that I just have to simply assign my L1, L2, L3. I'll just go and simply check that if my group size, I'll just simply copy this up, group size dot size, because it's a vector, right? It's a vector. If it is more than equal to 3, then I can just simply do one thing and assign my L1 as group size of 0, L2 as group size of 1, and L3 as group size of 2. Else if my group size of size, if it is more than equal to my 2, then I'll just say that assign only L1, which is group size of 0, and assign only L2, which is actually nothing but group size of 1. Else I can simply say that assign my L1 as group size of 0. Now when I have assigned my L1, L2 and L3, I have correct L1, L2 and L3. Now I will just simply go back onto this condition and say if my L1 is equal to L2, and if that is like more than my L3, so I'll just say that if my L1 is equals to my L2 and also my L1 is more than actually, or L3 is less than my L1 or L2, anything, because both are same. So my answer, let's initialize our answer also. So I'll just say that my answer is by default a 0, or I can say by default a -1 as a value, or my answer, let's have it as a, oh, that's a sign, okay. By default the answer is a -1, because you saw that I have to return a -1 here, so by default the answer is -1. If this is the case, which means my L1 L2 are there, so my answer can be a L1 -1, as we saw. Answer can be a L1 -1 again. Now I'll just say else if. I should not say else if, because if my answer is this, it is still valid. It's a valid condition, right? L1 and L2 can be same in this condition also, so I have to maximize this condition. So I'll just say maximum of these 3 values, which is answer, L1 -2 and L2. So I just say that if your L1 plus L2 plus L3 is more than equal to my 3, which ultimately is simply saying that I have a valid length of 3, right? I have a valid length of 3. I have a valid length of 3. Now I'll just simply say again, whatsoever you have to, guys, comment down below any doubt whatsoever. So answer should be maximum of answer else L1 -2 or L2, and simply return the answer here. Return the answer. Let's quickly test if we did not do any mistakes. And it's taking long. Okay, it seems correct. Let's submit, and it's a wrong answer. So output is 0, expected is -1. Okay, output is a 0, expected is -1. So okay, L1 is L2. Okay, so here this condition was not checked, that if both are there. So I solved Shashank. Yeah. I also solved C by binary search itself. But yeah, that's how more approach we can go off to, is this approach itself. And yeah, as you can see that here it can happen that my L1 -1, which means my L1, L2, as you can see, my L1 is 1, L2 is 1, and L3 is 1. Sorry, my L1, L2 and L3 all are 1. So it will go into this condition and my answer will become 0. So it will simply return a 0, but it's not possible to have 3 as same. Sorry, my L1 and L2, as you can see, L1 and L2 are actually both 1s, and L3 is 0, which is by default 0, as you can see, by default 0, which is not a good condition. So I should do one thing, rather I should initialize my answer with 0, and if I say my answer, if the answer is a 0, then simply do one thing, get the -1, else give the answer itself. Now let's submit and see. Let's try, and okay, wrong answer. JKKJ. Again, its output is -1, answer is 1. Okay, so answer can be a 0. So answer we should not assign here, rather I'll just say that if both are equal, if my L1 and L2 both are equal and my L3 is less, coming on back, my L1 and L2 both are equal and my L3 is less, so for sure my possible valid candidate can be a L2 minus or L1 minus 1 or a L2 minus 1, both are okay. Now if the possible candidate is this and I'm not writing this condition and I'm saying I'll go and simply check this L2 itself, L2, now considering the exact same condition, L1 and L2 both are same and L3 is 0, so it will just say answer is my, as you can see, my condition, okay, going back down, it is JKKJ. So L1 is a 3, L1 is a 3, L2 is a 1 and L3 is a 1. So for K it is L1 equal to 3. Now my output is -1, but I have the expected output as 1 because I can just take this L1 minus 3, I can put it here itself. So L1 minus 3 would have given me a value. L1 minus would have given me a value itself. Why in our case we are getting a -1? Why? Because it is not equal, so it will not land here. So L1 minus 1, L2 minus 1, it is more than equal to 3, so it will go and land here. Maximum of answer is 0. L2 is a 0, L1 minus 2, it's a 1. So okay, my answer needs to be maximized and saying that the answer have been a 0, it's a -1. What's the issue in this? Let's take only K. Oh, I'm assigning in my answer. Oh, I'm assigning in my answer here itself. Oh, okay. So it's of no point. I'm assigning itself in the answer itself, which is not okay. So I should do maximum of answer comma and this value. Take this case, run it here and see. Let's see. And again, okay, now we have a 12. We can easily see we have a E. Okay, we have some E's, some B and some M and then some F and then some E again. Okay, answer is 12. That's completely true, which means it lies onto this condition L1 and L2 because E is the answer. 1 2 3 4 5 6 7 8 9 10 11 12, right? Yeah, 1 2 3 4 5 6 7 8 9 10 11 12. Okay, 1 2 3 4 5 6 7 8 9 10 11 12. 1 2 3 4 5. Oh, output is 12, the answer should have been 11. Got it. So it's only because of this condition right here, because my L1 L2 would have been equal, so my E's and E's are both equal, so my answer here would have been 11. But as soon as it landed here, my L2 is still saying it's 12. L2 is still a 12, so it landed onto 12, which is not correct, obviously. So here instead of L2, what I can do is I can just say that reduce my L2 by 2, reduce my L2 by 1. If this is the condition, so L2 is reduced. Now L2 will be checked here itself and it can be initialized because L1 minus 2 will be because of the condition which we showed. This condition L2 is the new L2, the valid L2 which can be there. It can be because of optimizing with this condition itself. Now copy this again And that's the reason I showed you this last approach was the one because of which you will see a lot of wrong cases also. But again, it can be solved with binary search, which will not encounter much wrong cases. But this is a case, again, now it's accepted. So yeah, that's it. It's a kind of a case heavy approach, which I'll not recommend to take in the contest, because normal approach is much more beneficial. But the benefit of this case optimum approach is you can solve this in O of n time and O of n space, which is the best approach. Cool. Now we'll quickly go on to question number 4th, right? If you have any doubts whatsoever up till so far, then please comment down below. Else, can we please smash that like, maybe that would be super great. Cool. If it is not, if we have 3 characters, answer will be 1. Yeah, that's true. If it is not, if we have 3 characters, the answer will be 1. That's true. Yeah, that's the condition which you have to handle out. Cool. Now we'll go on to question number 4th. Question number 4th. So yeah, it's actually logic wise it's easy. Again, implementation wise, it's gonna be hard. Let's see that what it says. It says that, again, just comment down below that what you guys thought of that, what should be applied in this question. It's a big question though. Palindrome rearrangement queries. It says that you are given a 0 indexed string s and have an even length of n. So n is always even. N is always even. I can bifurcate that. Let's put it like this. N is always even. N. Now you are given a 0 index 2D array integer called as queries, where queries of I is this. Now I have given a query and the query looks like this. Now what it means is this starting AIBI says from this left half, which is from 0 to n by 2 minus 1, both are completely taken. As you can see, 0 to n by 2 minus 1, I will have AI to BI, and then for the remaining part, which is n by 2 to actually n minus 1, again both taken, I will take Ci comma Di. It is the ranges which they are representing. This is this range and this is this range. That's it. Okay, cool. Now what I am doing for each query, my task is to find out, or basically to say that it is possible to make my S a palindrome by performing the operations or not. I have to figure out if it is possible to make my S as palindrome by performing the operations or not. I have to figure that out. Okay. Now what's the condition of palindrome? Palindrome is, a condition for palindrome is, if I just represent that exact same string to me, and again the length is exactly even, so for sure I can compare every character. Palindrome is that this character should match the character right here, the character right here should match the character right here, and the same goes for this, right? This is the condition for palindrome. So I have to just figure out that if it's a palindrome or not. Now that is true, but what is the operation which I can perform? Operation which I can perform is as simple as that. I can rearrange the given query, or basically the given range which I am given. As you saw that I will be giving a range in the left part. I'll be giving the range in the right part. For that specific range which is given to me, I can rearrange those characters, which means, and again it's a range, so it's a range. So let's say if I project this left part and make it bigger, again I'm just projecting the left part and making it bigger, so it is only the left part, and I am given a AI to BI as let's say like this. It is my AI to BI. It is like this. It is AI to BI. Now this AI to BI, which means this AI to BI is a range. I can rearrange these characters inside. So here, if it was A, B, A, D, and E, I can rearrange that and make it and again I can rearrange only this specific range. I can make this entire range as E, B, D, A, and A. Anything whatsoever I want, I can rearrange that for. Okay, that rearrange portion is done. This is what I can perform. Okay, that's great. Now that I can also perform for the right part, which is the right portion which is given for me. Rearranging part. I have to figure out, or I have to tell each query is answered independently of the others. That's great, which means one query when I will go and ask, okay, left part rearrange this portion, right part rearrange this portion, and go and check if the string formed is a palindrome or not. I'll go and check. I'll simply say true or false. If I say true or false, no matter what, I will bring my S again back to my original location, and then I will start applying my next query. So basically it is saying that every query is independent of each other. Okay, very fair, very fair. It just says every query is independent of each other's, and I have to return the zero digit array called as answer, where answer is saying for this specific query, if I apply the operation, can I make this string S after applying the operation as a palindrome or not? That is what I have to give me as the answer. Now, one very basic and very obvious thing which will come in your mind is, bhaiya, what I will do is I will just go and see, okay, I will just go and firstly write my string S, ABC. Again, I will write that everything in baksa. If it is my string S, indexing, I'll just write, okay, 0, 1, 2, 3, 4, and 5. And always bifurcate that with the mid. Mid is bifurcated, N is my 6. Now, I just simply say, okay, I'll just go on to my first query. I'll say, okay, it's my first query. If it's my first query, then I will just copy the entire thing down below, paste, and okay, let's say I copy the entire thing down below, and I just pasted that. And I wanted to apply my query on, I'll just also write, okay, 1, 1, 3, 5. It is saying 1, 1, 1, 1, and 3, 5. It is my query 1, which I'm going to apply. If I'm going to apply this specific query, I can change this L, R. Let's name it as L1, R1, right? This is L1, R1 range, left range, and this is L2, R2, right range, right? So it is L2, R2, L2, R2. It's a right range. I can simply do one thing. I can just shuffle them up, right? I can just simply shuffle them up. Now comes the interesting part. The range which is fixed, you would be wanting to bring out, you would be wanting to bring out this entire part same. So what could you do is that you will say, bhaiya, this part is same. So what I can do is I can just go and try to make this part, because see here I cannot rearrange this left part. So what I can do is I can just go and say in the right, whatsoever is rearrangeable, remove A from here, or remove A from here. Okay, I removed. Now I'll go and try to rearrange this fixed. Again, this is a fixed portion which I'm trying to remove in the possible rearrangement. Again, for this right part, this is fixed, it cannot be rearranged. I'll go and remove this right portion in the possible rearrangement which I could have, and then remaining part I can simply compare. It's a BB, it's a equal, so it's a valid rearrangement. So this is the first hint of how this could have been solved. That I just tried, okay, with the example itself, I just tried that how I can even figure out that after rearrangement things should look equal. So, but bhaiya, what about the palindrome? What about all the stuff which we could have heard of or we could have done of? We will see that. We'll gradually go on to how we will approach it. But it is the first approach which we saw, or basically while seeing the question itself and to figure out that what could be the answer, we just firstly saw that, okay, A is fixed. Again, remember every point will be useful. A is fixed. And I know, again, I'm not saying I remove from somewhere which is not fixed. A is fixed. So I just tried on and say, in this rearrangement, remove A. In this possible rearrangement which you can do, simply remove A. Because ultimately, if you can simply remove A, which means after rearrangement, you will be able to bring your A at this location. Wherever it is, you will be able to bring your A. But bhaiya, A is not here. A is here. Yeah, bro. Anywhere, you will be able to bring. Okay, that's great. For C, again go and remove wherever your C is there, remove it, because you will be able to always bring C here if you have a C. Now bhaiya, it seems like understandable, but still I cannot understand much, because yeah, you will not be, because the example is very small. We'll go on to bigger example, but the intuition which you have got, okay, so far. But bhaiya, okay, even if you remove the characters which were fixed, the characters which were fixed, even if you remove that, but bhaiya, what about the characters which are actually there? Which means will, although here it is just one character compared to one character, but I have to compare the entire substring. So bhaiya, will you compare the entire substring and check if it's a palindrome or not? Did you remember? I can rearrange this also and this also, right? So let's imagine my L1 and R1, L2 and R2, right? Let's imagine my L1, R2 and L2, R2. Now, as I'll take the exact same example. I had these specific strings, these specific characters in my L1, and some characters, and like I'll take the exact same. L2, R2 is big. L2, R2 is big. L2, R2 is big. L2, R2 is big. Right? I took the same characters 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Cool. Just to showcase, exact same. I just made it bigger, a bit bigger. Now, simply saying one thing, that I had something like prior to L1 also I had something, which is, you can see A here. So I knew that I will have something. This should be matching with this. This should be matching with this. And I will also have something. This should be matching with this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, it's 2, 2. This should be matching with this, right? Now bhaiya, when you say matching, this is fixed. This is, let's say, DC. This is, let's say, AE. So it is fixed, because you can only rearrange this L1 R1 and L2 R2. So what you can do is, you know that you can rearrange this red portion, and you just wanted to make it equal to AE. That is what you want ultimately, right? So simply do one thing. And again, I'm concerned about only the alphabets. Alphabets are just 26. And I'm only concerned about A and E should become with this specific range. Again, why I'm saying range, I'm not saying specific characters. I'm saying specific range. Why specific range? Because I can rearrange them. So I want that this range, if I get the frequency of every character, again, this range, if I get the frequency of every character, which is A, B, C, D, E, up till Z, then A should have a frequency of 1, E should have a frequency of 1, rest all should have a frequency of 0. If this is the case, then I will just simply say that, okay bro, it is matching with my this red range. Okay, great. Now bhaiya, what about okay, that is done. Okay, if this again bhaiya, but you will have to find the frequency of all the characters in this range. So will go on to the entire range and will go and say, okay, update the frequency? No, we will keep a prefix sum of frequency. If you don't know prefix sum concept, it just says one thing, that if I have characters A, B, A, D, E and D and B, then my prefix sum of frequency concept says I will keep track of the prefix sum of all 26 characters, which is A, B, C up till Z. C, D, E up till Z. I'll keep track of them. Right? I will keep track of them. Here I'll say, okay, prefix sum, it will actually become a 1. Here corresponding to A, it is 1. It will say, and again, it's a prefix sum. So I'll keep on updating. Okay, A is 1, B is 1. I'll say, okay, A is 2, B is 1. I'll say, okay, A is 2, B is 1, C is 0, D is 1. I'll say A is 2, B is 1, C is 0, D is 1, E is 1. I'll say A is 2, B is 1, C is 0, D is 2, E is 1. That's how a prefix sum is stored. Okay, I'll say here A is 2, B is 1, C is 0, sorry, B is 2, D is a 2, and E is a 1. Right, that's how I'll show the prefix sum of the frequency of the characters. Now bhaiya, what is the use of this? The use of this is, if I want to know, okay, in this range to this range, in this range to this range, again the range can be pretty big. If you go on the constraints, the range length of the string can be pretty big, right? So I have to get this count in very short time. I have to get, okay, I know that in this range, which is in the left range, red range, I have to figure out all the 26 characters, what is the frequency, and again I have to go and figure out in this range, which is the red range. Again, I'll number the ranges later on, but in this right range, I have to again figure out that what's the count of all the 26 characters. If this count is matching, it's good. I will be able to rearrange this portion to get it equal to my right. But if it is not, it's impossible. So I have to get this frequency of all these characters. So if I just go and ask you, but bro, what's the range? What's the frequency? So ultimately, I'm asking you, return me this entire thing for all the characters A, B, C, D, E, and so on and so forth. Return me. So you will do simply one thing. You will subtract this value from this value, which means if it is a I, it is a J. So you will subtract your prefix sum of frequencies of J minus prefix sum of frequencies of I minus 1. So as you will see that if I just write this entire thing down, so your A frequency, which is 2, let's take it, it is 2, it is 1, it will become a 1. It is a 1, it's a 1, so it will become a 0. It's a C is a 0, it's a 0 here, okay, it's a 0. D is a 2, D is a 0, 2, E is a 1, E is a 0, 1. So you will see the frequency you will be able to figure out in O of 26 time by just simply pre-computing this entire prefix sum array in O of n into 26. Right, you will be able to figure out this frequency part. Now you will be able to figure out, as you can see, A is once, D is twice, D, and E is once. Okay, so which is actually equal to O of 1. It's constant. So now you are able to figure out the red portion frequency of all the characters. It should be matching exactly with this red portion, which is fixed on the left part. And for the side part, which is the orange part, again, you can just go and figure out the frequency. It should also exactly match with this specific range, which is this range, which is the orange part. Again, it is fixed, it is variable. So it should match. Which means the frequency should match. That's it. Okay, I'm not concerned about the arrangement. It's just that the frequency should match. Arrange, I'll do by myself. I'll arrange. Okay, it should match and this red should match. Now for this remaining portion, which is the blue portion, for this obviously the green portion which I've showed right here, this green portion, again the frequency of this and this should match. It should match. But bhaiya, okay, the frequency will match. Yeah, if the frequency matches, I know that I can rearrange that. Okay, if it's A, B, C, D, I can simply arrange that as a D, C, B, A to get the answer. And that is the ultimate crux which you have to go and figure out for this entire problem. Again, it's just the intuition. Now we'll go on to the solution. But again, the intuition just says that you will have the range, which means you have the string. It is a string left part, it is a string right part. I just put that as two different strings. String left part is right here, string right part is right here, and then I will just go and say, and again I'm more concerned about the frequency of characters because I can rearrange them anywhere whatsoever I want. But bhaiya, what about the remaining ranges which are not even considered here? We will go on to it, but mostly we are considered about the frequency itself. Of the character itself. Now any questions to is related in the lead code? Any questions to which question 3 is related to in the lead code? I guess there are many, there should be many, but it's just a mixture of binary search, sliding window, and cases. So like binary search and sliding window is one option, Cases another option. Cases is kind of a ad hoc problem, but binary search and sliding window you will find many problems. Just write binary search, sliding window, Leetcode, you might find a combination of it. Or you can also go on to our sheet, which is 169 series. In that there will be a problem considering a combination of binary search and sliding window. Now coming on back, now this was the thing which we can do is that for every query I will just have to go on to my L1 R1 L2 R2, which means for every query I will just specifically check for a few ranges. For every query, my operation should be just a O of one operation. For every query, my operation should be just a O of one operation. Now I will come down to a solution that how for every query we will figure out the solution to be O of one operation. Now let's take our string as our main string. This is our string S. I bifurcated my string S saying it is 0 to 0, 0 to n by 2 minus 1. That is part, and it is n by 2 to n minus 1. This part. Now again it's a part. My ultimate aim is to make it a palindrome. Remember, मकसद नहीं बोलना है. It should be a palindrome, right? And I would be given some ranges for me to consider, which is L1 R1 I will be given and L2 R2 I will be given. Right? Again, my ultimate aim is to make it a palindrome, which means these things, this character should match with this last character. Right? Now, matching with the last character might be a bit tricky to understand. So what I will do is I will just transform this and take, okay, the left part, I will take the left part. The right part, I will reverse it down. And I'll consider the right part as, again, this L2 R2, so it will modify as L2 dash R2 dash, right? Although it's a dash, but I have written L2 R2. Just carefully modify that L2 R2 also. So these will become a L2 R2 dash. Although I have not put the L2 R2 dash, but remember this. I have reversed down. This is reversed. So you will see it will be 3 in the beginning, so that I can compare I to I. I don't have to go and compare opposite characters. It is for the simplicity. I just reversed it down. Okay, again, it will be L1 R1. Again, it will be 3 characters here. You can see 3 characters. Again, it's length n, and I have bifurcated at the specific length. So count will always be same. So don't worry on that part. And again, for this, let's say I have 2 here and here was 2. So I just say 2 here and here was 2. And again, in the between, let's say I say it is actually 1, 2, 3, 4. And let's say it is, let's say it is, or I should have done much more better. Oh, let's say, let's take it as 1, 2, 3. Let's take it as 1, 2, 3. It is take it as 1, 2, 3, 4 and 5. Okay, 1, 2, 3. It is 1, 2, 3. It is 1, 2, 3, 4 and 5. So I'll just modify a bit one thing, that that this portion, this pink portion. So I'll just say that one pink is here, right, and one blue is here. Okay, and also one pink is here. One pink of this is here. It's just for you to show, like, represent that how I have modified my left part and right part. Right? I just modified. I didn't do anything. I just reversed this entire right part and got my entire right part as new part. Now comes the interesting part. Now again, it is from 0 to n by 2 minus 1. Again, it is n by 2 to n minus 1. It is this entire part. Now I just represent that left. It's just one string. Left part is the left string, right part is the right string. So 0 to n by 2 minus 1, n by 2 to n minus 1. And remember that the right part is reversed. So I don't need to check this part to this. I don't need to check this part to this part. I can simply check this part to the specific character. I can just compare from left to left. I don't have to compare from left to extreme right, right? Left earlier, because for palindrome, it should be I to n minus 1 minus I. But now I have reversed it, so I need to compare only this to this. Okay, great. Now comes the interesting part, that I have given you this range. Again, to compare ranges, that both ranges will result in the same cutter or not, you can rearrange that. For the rearrange part, you can rearrange that, and for the rearrange part, you always obviously know that if I can rearrange something, then I'm very good with, okay, I should get the count between that specific ranges. But bhaiya, what all can be the ranges? Just let me know that part. Right now, I just made a hypothetical example. As you can see, the left range is small, right range is big. If you don't get it, I'll just put it here. Left range is small, right range is big. If I just make a representation of the right range, I just made the representation of the right range on the left part. It would look L2 here and R2 here, R2 here. It's a representation of the right range on the left part. Now, this obviously shows me that the portion which I can rearrange is this entire portion. The remaining portion, again, the remaining portion is fixed. So this entire portion is fixed. 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 So one thing is for sure, that this entire portion should match character to character. This left portion should match character to character. And again, this left portion should match character to character. This left portion should match character to character. So, bhaiya, how would I know that something is matching character to character? So what I can do is, as you saw that here, I made a prefix sum array just to know the count, of characters in a range of one time. But here I should, okay, for this mid part, my frequency array will be used. But again, and you always remember, right? You remember, it is a reverse thing. It's a reverse string. It's the reason I'm comparing the left part to left part only. Okay. Now, if you know that, just one thing, that we have to now get character to character match. I'm not saying frequency match. Frequency match can work for the rearrange part, but character to character match I need to have. So what I will do is, I will make a new array, or basically a new prefix array, which will say, okay, for the left part, let's name, okay, my string S was a big string of 3 characters. Sorry, my string S was a big string of 6 characters. 1, 2, 3, 4, 5, and 6. Right? I just bifurcated into mid. So S1, which means the left part, let's say S left, and it is S right. I will have 3 characters here and 3 characters here. Now ultimately, I also reversed. S right is also reversed. It is also reversed. Right? So I just need to check that this character is equal to this is equal to this is equal to this. That's what I need to check. Now, coming on back, I'll do one thing, that if this is a A, this is a B, this is a C, this is the A, it's let's say A again, it's a A here, right? And it's a B, it's a C, and it's a C, it's a, let's say, D. So A, B, C is the left part, A, C, D is the right part, right? I will just make a basically equal prefix sum array, right? I'll make this array, which will say me one thing, that if this is the same, okay, 0, which means if this is same, then okay, it's good for me. It's different, it's not good. If it's different, it's not good. So I'll keep track of this prefix sum. Okay, 0, or let's say here it would have been a C only, so I would replace my D with C, so it would have been a 0, right? So I am just keeping track of this prefix sum portion, just saying that okay, here the prefix sum is 1, so equal prefix sum I have maintained. so as to why this portion you have to maintain, because you want to know if exactly equal matches or not, so what I will do now is just to figure out if some range is exactly matching or not. So I have this range, let's say L to R. I know if this matches exactly or not with the other range of S2 or not. So I will just go and find, S, let's name this equal prefix sum, EPS array. So I'll just say EPS of R minus EPS of L minus 1. So it will give me EPS of R is 1, EPS of L minus 1 is actually also a 1. It is a 0. And again, it's for all the characters. So it is for all the characters. This array is for all the characters, right? Sorry, it's not for all the characters. It's just a prefix sum array. Just saying, okay, if because I don't want all the characters count. I just want should be exactly match. So this EPS array will just simply go and let me say that this specific thing, if it's matching or not. And again, quickly comment down below anything whatsoever guys you are thinking or have suggestions, unless you will interact or give out your opinions on what could be the possible next approach. Again, let's say if I am explaining this, if you have got the hint at any point of time, okay, what could be the next step, just keep on writing. Unless you will keep on parallel thinking, you will never get the approach entirely. It's the reason I always recommend in my videos also, main videos also, keep on pausing the video and keep on thinking at every step. What could be the next step? Now, okay, I thought this, then Bhaiya told this. What was the difference? Like this, keep on going. Now, this will make me sure, okay, equal prefix sum array is 0. Equal prefix sum array is 0, saying that this entire range has the sum as 0, which means all of the characters in this range were matching, right? If you have the sum of some range as 0, and again I am saying that the values are either a 0 or a 1. If this is a 0, so for sure all the elements should have been 0. So if a range sum is a 0, then all the characters should be a 0, which means all the characters were actually matching. If it is a matching, if it's a value 0, which means I'm good. This range is matching. My S1, S of left and S of right of this range is matching. That's great. And for sure, if I would have asked you this L to R, then this L to R, right? So you would have given, okay, EPS of right is actually EPS of right is actually a 1, which is this. EPS of left minus 1 is actually 0, minus 0. So you are getting a 1, which means one character. See, the value is 1. Now it is a equal prefix sum. So this value can be anything. It can be a 2, 3, 4. It's just that underlying values can be a 0 or 1, but which means these values. But the prefix sum, it can go to any value, which means, let's say if I would have added one more, let's say if I would have added, let's say a D, and I would have added a E here. So corresponding to it will give me a 1. So here I would have added the count as 2. So this equal prefix sum value, it can be very high value also. It's just that a some value. Now if it is a non-zero, as you can see here, it is a 1. It's a non-zero value, which means I have at least one of the characters which are not matching. So I will now have this exactly equal prefix sum, which saying, okay, exactly match thing I also need to have. Now coming on with this pre-computation of equal prefix sum, I will be able to know that, okay, the specific range is exactly matching or not. Now I'll do one thing, that I want to know that this range, Bhaiya, what is this range? This range should be matched exactly equal to with this range, which means range from 0 to minimum of L1 comma L2, as you can see, minimum of L1 comma L2 should exactly match, right? And this is, we can check with this, that's it. And also that from maximum of R1 comma R2 to actually n minus 1 should exactly match, and the reason I have reversed it, so I just have to compare the exact indexes itself. Now this should exactly match. Okay, exactly match part is done. Great. Now comes the mid part, which is the rearrangeable part, which means, okay, and again, at any point if you violate any condition, just simply return a false, which means just simply put in a false for corresponding that query. Simply you can put in the false. So my ultimate aim is to figure out if it's a true or not, which means if it is actually possible to convert that to a palindrome or not. Now it's as simple as that. We have gotten the exactly equal. Okay, it should be exactly equal. For that I have just did a pre-computation. In this, the pre-computation plays the entire role so as to get the value of every query in O of one time. Now we'll go on to comments later on, no worries. Just quickly, but any comment which says I solved using binary search, they had too much of casework, should it solve after contest, should just solve just after contest. Yeah, that's true, Shashank, that's great. Firstly, any questions to which questions related to in Leetcode? That's like I just told, maybe you can search for, I'm not sure right now, I can try on and get on the Telegram channel. If you're not joined, you can just go and join that, link will be down below. But in that we keep on discussing about codings, approaches, all that stuff. It's a community for us. You should make it recorded and then put it on stream instead of solving it right now in front of us. See, it's of no point of putting that on stream after recording, else I won't be able to communicate or basically get your approaches and get my approaches also. Because like stream, else like I'll simply record it and put it as a public video. But stream is just for you, like you guys to interact and have your doubts. Anything whatsoever you have, you can just get that cleared. And see, if I'm running a specific test case in the run, it's giving me correct output, but as soon as I am submitting, I'm getting a TLE. What is the problem? Yeah, like when you run a test case, while running the test case, the bandwidth of TLE is much more high, but while submitting it, it is very restrictive and fixed. So because see why it is allowed, so that you can also have your print statements while you are running your test cases, but when you are submitting it, you have to comment all the print statements also. So it, like for example, while submitting your your limit is, let's say, exactly equal to 1 second, but when you are running your test case, your limit will actually be allowed to, let's say, 1.8 seconds or 2 seconds. It is allowed so because you can also have a print statements to debug your code. That's the reason. And print statements are heavy. That's the reason it is allowed a bit more time complexity while you are running the code in actually compiling and running. But while submitting, it's a fixed time constraint, which is you can see with the problem constraint itself. Now coming on back, the exact match part was done. Now comes the remaining part, which is this left part. So what I'll do is I'll simply copy this entire thing, and now again, considering the exact match part was done, now we will try to do it for the remaining part. Now bhaiya, what was the remaining part? Remaining part was this part of L1 R1 and L2 R2, right? Exactly same as what we saw above also, that I will try to push in my L1 R1 and try to make it here itself, L1 R1. Now again, don't consider this left part. It is already checked. Don't consider this, already checked. Don't consider this. Now what I will do is I will just say, bro, match this left part, which means this is a fixed part for string left. For string left, this is a fixed part, right? Which means this for string left, it cannot be rearranged at any point of time. But for string right, I can rearrange that. So get the frequency of all 26 characters. And this frequency, I'm not saying the exact match. This frequency of this portion should match exactly with this portion, right? Again, the same concept for frequency of this portion. Because bhaiya, why I'm doing the frequency of this portion only? Specifically, why it's different? Because this is a fixed part. This cannot be changed. This cannot be rearranged. So the frequency will remain fixed. So get its frequency and check it in this left part. Now this is by explaining, but you will see while coding what we will do is we will get the frequency from this part and then we will reduce the frequency in this portion, or basically in this entire L2 to R2. Let's name the L2 to R2 frequency array as let's say V2. Let's name the frequency array of L2 to R2. When I say frequency array of L2 to R2, I mean the frequency of all the characters in this range I have got in the entire V2. So what I will do is I will get the frequency of this range, which is L2 to L1. I'll get this frequency and I will subtract these frequencies in this V2. That's what I will do in code. But for explaining, what I am ultimately wanting to do is basically my mind is wanting to do is will get this frequency of the red portion, it will get the frequency, and then it will try to say that this frequency should exactly match with this left part, right? Now bhaiya, one thing, this frequency is not this frequency, right? It can be rearranged, which means L2 to R2 can be rearranged. Yeah, that's true. It is the reason what I was saying, while coding itself we will get the frequency from this left part, which is the fixed part, and the V2 portion, V2 will be the frequency of V2. This V2 is the frequency of all characters in L2 to R2 range. I will have this frequency array like this. Now this frequency array, I'll go and subtract. Let's name it as remaining, or basically let's name it as V of L2 L1. It's again a vector of frequency of all the 26 characters. I'll go and reduce it into this, reduce it from this V2, which ultimately would be meaning that I will be able to achieve this red portion. And the same goes for, let's say, this pink portion of this pink portion. I will again go and make, let's say, V of R1 R2. It's again an array, again the frequency of characters, which I can easily go and find it over one time. I showed you how, by using this particular prefix sum of frequencies, and I will again go and subtract that in from this V2. Again go and subtract that from this V2 so as to get in, okay, okay, I will be able to get this portion. Bhaiya, but you are subtracting. Are you subtracting blindly? No. I am subtracting, which means I'm expecting it should match. I'm expecting it should match. If it is not matching, which means ultimately, if this frequency is not exactly 0, if this frequency is, again, please go and do again, if this frequency is not exactly 0, or if this frequency is less, let's say less than 0, for sure it's not possible. So again, I'm just going and saying this frequency which I am making right here, I'll just subtract its frequency count in this V2, because I know that V2 is L2 to R2, and L2 to R2 I can arrange very clearly. So that is always possible. That's always possible. So simply get this one thing, that simply subtract this. Now, okay, bhaiya, after subtracting, what if it becomes a -2, which means, okay, it was not a valid thing. If it is not equal or basically becomes a -2, I'll simply return a false, or say false. But what I mean by that is I'll simply go and in last compare this. So I'll just simply go and say, bro, make a V1. V1 is the frequency of all characters in L1 to R1, which is this particular frequency of vector. Now ultimately this V1 should match with V2 again after subtracting V of L1, V of L2 L1 and V of R2 R1 or R1 R2. After subtracting, this two should match. If these two are matching, I am good to say that it's a valid. Okay, like you can for sure any day form the valid palindrome. This is the entire crux of the solution. But you will go and say, Bhaiya, in this case you considered that your L1 R1 is like this and L2 R2 is a wider range. But you can have multiple cases. L1 R1 is like this, L2 R2 can be like this. It can be also possible that L1 R1 is like this and L2 R2 is like this, right? It can be also possible that it's just that your range is bigger, smaller. It can be left, right. There are many possibilities which could have been there. So how will we handle that, bhaiya? Which means here it can also possible that okay, L2 R2 is here and L1 R1 is here, because it's a range sizes for left and right. It can be bigger or smaller. But bhaiya, L2 तो हमेशा बड़ा रहेगा ना. L2 is a number which will always be bigger. I'm not saying number, I'm saying indexes, which means I bifurcated my both the arrays to a zero based indexing. It is a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It is a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Like this, I have bifurcated both of my arrays to a zero based indexing array, and then I am going and checking that okay, what is the corresponding LNR saying what portion I can rearrange. So there are multiple possibilities. So what I will do is all those multiple possibilities I will boil it down to 4 possibilities. How? Like this. So we know one thing, that one thing can be possible is that my L1 is here, my L2 is here. Forget about R2, forget about R1. If it is like this, then I know that and again my L2 R2 is here, because okay, it's the imaginary portion of L, because for the left it is for string 1, for the right it's for string 2. So for the imaginary portion L2 and for the imaginary part of L2 it is L1, right? So I know one thing, that what I will do is I know that it is L1, it is L2. So this portion is fixed for L2, for string 2. So I will get the frequency from this portion, which is L1 to L2. I'll get this frequency and I'll subtract that in the frequency of V1. Again, remember a few terms. Let's write these few terms. So V1 is the frequency of characters. From L1 to R1. Both inclusive. Everything is inclusive. Whenever I write, everything is inclusive. V2 is the frequency of characters from L2 to R2, right? That is V1, V2. Now I am saying that get the frequency, get the frequency from L1 to R1. Let's name it as a FL1 L2. Get this frequency, subtract that from this V1, which is F of L1 L2, right? Get this and subtract this. Again, you might say, Bhaiya, what about you are getting the L1, you are getting from L1 to R2, you are getting from L1 to this specific L2 only with this, but what about my R1 itself is less than L2, then what? No worries for that. But here are some of the cases which we can handle, which means you are just mentioning, again, that's the reason I'm just saying, comment down all the approaches which you guys are thinking right now. L1, L2, R1, R2, all the approaches, but still I'm going and telling that now you know that you will go and figure out the frequencies. But bhaiya, one thing, to go and figure out for the range, I know, okay, L2 is inclusive, which means L2 is inclusive. So I'm just trying to figure out L2 minus 1. Remember that, okay? That's one thing which I was about to miss. It is L1 comma L2 minus 1. In this range, the characters whatsoever are there, let's name it as F2 L1 comma L2, or you can name it as anything whatsoever you want. I just named it like this, and this should be subtracted from V1. Again, but there can be one case that what about this L2 minus 1, because what if your L1 ends here, which means your L1 R1 ends here itself, so it's of no point. It's of no point to subtract this value. Okay, my battery is dead. I'll just I don't know, I was late to the stream, I tried button search. My battery is dead. I'll just quickly try on for some alternative. I don't like this, but yeah, I'll just remove the circle filter and I will have a plain display. Green screen, DSLR, my main camera, okay, and this green screen, okay, yep, that's much more better. Cool. So yeah, that's much better. Now coming on back, so it can be possible that my R1 even ends before L2, so it's of no point whatsoever to subtract this value, this huge value from the small value, right? So what I can also do parallelly is one thing that I'll just say, take the minimum of L2 minus 1 comma this value, which is R1. Sorry, take this as a dotted line, take this as a R1, right? This is considering what I have done for the left part. Here, taking this rather than taking this, take this value and then subtract it. Okay, that is you do for the left portion. Considering left portion is L2 is less. Again, it can be else condition that your L1 is less. If I just pull back up, it can be that your L1 is here, your L2 is here, as what I discussed previously also, and your L1 is dotted and L2 is fixed, right? So this is a portion which you will grab. You will grab this portion, and again you remember it's a V2. You'll do a V2 minus some value. V2 is for L2 comma R2. So you will grab this portion. What's the frequency of this portion? Now again, comment down below what's the frequency of this portion. This frequency, comment down below what should be the frequency of this portion. Again, this frequency was frequency of 2. We have a different frequency area for the right part, so it's a frequency of 2. And we just do a F2, let's say F2 L1 comma L2. Again, for this portion, comment down below that what could be a possible option. I'm just saying that I wanted L2 to L1 minus 1, the frequency from left string, from left string, and this frequency which is F, which is let's name it as FL2 comma L1. Again, that's from the left part, which is the string 1. This thing, it can be the minimum of whatsoever is there, L1 minus 1 or L1 minus 1, or it can be R2 also. Whatsoever is minimum, just get that. Just get this portion of frequency, right? Just get this portion of frequency. When you have this portion of frequency, you can go and subtract it from this FL2 comma L1 from 1. Considering it is a if else condition, right? Either it can be this thing or this thing. If I can just say if my L1 is less than L2, else, which means else indirectly means my L2 is less than L1. Now the same condition will follow along for R. For R, how? Like this. Let me change the color. The same, that's exact same condition. That if my R1 is like this and R2 is like this, and same R2 is like this, and my R1 is like this. So for sure, this is a fixed range. So you know that you will have a V2 for this. You will just grab a frequency of range R1 to R2, and then it is for the F1, which is R1 to R2, and then you can simply go and subtract that in V2, which is F of R1 comma R2, F of R1 comma R2, F1 for R1 comma R2, and do its subtraction. Remember this fact again, the same thing, that this L2 can be here, L2 can be here, L2 can be here. So instead of R1, take maximum of R1 comma L2, right? And again, it's simply R1 plus 1, because I'll do for this range, which is R1 plus 1. So here it is R1 plus 1. So take maximum of R1 plus 1 comma R1 plus 1. Okay, I'm writing R1 plus 1 comma L2. Take the maximum. And the same again, it's a if condition. It's a if condition. If my R1 is less than my R2, the same condition which I'll write down below, that what about my R2 is less than my R1. So R1 is here, R2 is less, and the same goes, my R2 is here and my R1 is less. So I will just get this entire string. This entire thing I'll get, which is actually nothing but R2 plus 1 comma R1, but this I should take as maximum of R2 plus 1 comma L1, right? This is the frequency 1, so I'll just name it as a frequency 2 of R2 R1, and I should subtract that from V1. So I'll just do V1 minus F2 of R2 comma R1. So that will be the else condition. And that's the only case. When the entire portion, now the other 4 cases which we had considered. Now when this entire portion is done, which means you have subtracted this red and this pink portion from each other, anyway whatsoever L and R combination would have been there, you would have subtracted that. Now ultimately will remain this portion will remain equal portion. This red portion is done, this red portion is done, this red portion is done, right? This pink portion is done, this pink portion is done, this pink portion is done. Again, in the green portion we checked strictly match. In the red and the pink portion, for the red portion specifically I checked it should be matching. For the pink portion I should check it should be matching. When I say matching, the frequency should be matching. Now comes ultimately, and when I say frequency matching for L2, which is the more range, in that you simply subtract, not specifically range I'm checking, I'm simply subtracting. I am subtracting, right? I'm getting the specific range and I'm subtracting from this variable range, because L2 R2 can be a big range which can be like rearranged. So I should subtract and not exactly match with this range, because again the characters from here can come here, right? So I'm just subtracting, and then ultimately I will have this bounded ranges, which means this white range and then this white range. Now these 2 ranges should exactly match, which means, as in, like when I say exactly, I mean the frequency should match. So I'll just go and ultimately say that V1 is the frequency of the left string, V2 is the frequency of the right string. Now this frequencies should be matching for A, B, C, D up till Z. Everything should be matching. The frequency should be matching. If it is matching, I'll say I can convert this as a palindrome, and for every query I will solve this in O of 1 time. So basically for Q queries O of 1 time, for one query O of 1 time, for Q queries O of O of Q time, right? O of Q time for Q queries. And for sure, the pre-computation part will require O of N time for this. And that is the only thing which you have to do for this question. Again, that's a big case question. Firstly, you have to, again, a bit recap I'm doing right now. Again, any question which you guys have, you can just comment down below. So if I do a bit recap, I'll just put my tablet like this. I'll do a bit recap. The recap says that I need to know the frequency of the range of characters. So for that, I will maintain the frequency of the range of characters by using a frequency of all 26 characters and then keeping a perfect sum of that. So as to get the frequency of all the characters in a specific range in O of 1 time. Now when I have done that, I figured out that there are 6 possible cases. One case is that the remaining left portion should exactly match. Right portion should exactly match. Exactly match as in I need to know that character to character it should match. To get that character to character match, I took as a array just which will keep track of character to character match. It should match character to character. So I just keep track of that equal prefix sum array, which will give me if that range is matching character to character or not. Okay. When that portion is also done, now when that portion is also done, now I am remaining with, now this is the portion which is the green portion which is done. Now I am remaining with the next portion which is red, pink and white. Now this combination, which means L1 R1 and L2 R2, it can be of multiple ranges. It can overlap, how much overlap, all that stuff. So what we thought of, let's bifurcate that into 4 cases. What it says, if L1 is less than L2, again, how much R1, how much R2, we are not much concerned of that. We just can handle it here itself, right? So what I did here was that I just tried to manage that and got that in my F. Like I just got that because it is a strict, it's a strict range, which means I just have got 4 conditions. So here it is L1 is less than L2. So in this right part, which means the string S2, I have this strict range which needs to be there. So I'll get this frequency of the strict range and I should subtract that from V1, which is the L1 R1, which will have, it can be rearranged. This entire L1 R1 V1 frequency can be rearranged. So I just subtracted that. Else condition is opposite of that. Same for R condition and same for R opposite condition. Now when this entire thing is done, when I have subtracted, so I have got this white ranges. Now this white ranges should exactly match. So I'll ultimately say that V1 and V2, both V1 and V2 are actually keeping track of all 26 characters frequencies, same, all 26 character frequencies, and then it should ultimately go and match. If that is matching, simply you have solved it. And say for that specific character the answer is true. Cool. Now we'll go on to its code. Again, any doubts whatsoever, you can just comment down below. And also I know that it's a bit lengthy question, having a bit cases, but yeah, that is what it is. Having a bit cases and a bit lengthy part, which can be, cannot be, depending upon how you guys consider that to be true or false. But I think that it should be the most easiest approach for this question to go about it, right? Now let's again quickly comment down below any doubts, comments whatsoever you guys have. We'll go on to it. Cool. There's a conversation between Shashank and Anand going on. Oh. Okay, cool. Now we'll go on to the code. Right, it's gonna be like, we'll just take a reference of our code whatsoever you write, although it's gonna be a bit big code, but hold on. And for sure, if any of you have any suggestions, doubts whatsoever, just quickly write down below. So again, in the very beginning, what's the obvious thing which we can do is we'll just say, okay, just grab the size of our specific string. Now why this size is required? Because many variations, because you need to take from 0 to n minus 1, 0 to n by 2 minus 1 and n by 2 to n minus 1. So you need to have that itself. So for that's the reason. Now I'll also take the answer. Now answer is nothing but the possibility. Now this possibility can be a true or false. By default it's a true. Any point it violates, I'll make it a false. Now I'll go on to my left portion. Now why I'm going to my left and right portion? I'm just keeping track of the count. I want to keep track of the count itself. So the very obvious case is if the count itself is not matching from the left and right. So what I mean by that is, if you have a string, now I just write the left part of the string. Left part of the string is A, B, C, D. Right part of the string is D, C, B, B. Right? Now it's a left part, it's a right part of the string itself. It's of the string itself, right? So let's name it as S1 and this is S2. And my main S is it's actually itself A, B, C, D, D, C, B, B. Right? This is my main S. So obviously you can see if the left and the right part are not even matching, not even matching, no matter even if I allow, okay, entire left part you can rearrange, entire right part you can rearrange, still you won't be able to make it same or make it a palindrome because even the character count is not matching. So what I will do is I will keep track of the character count. I'll say that on our map int I'll say character count. So I can simply go on to my entire string and or let's say I can see character count. So I'll just say character count of this part, which is S of I, it was simply plus. Now I'll go on to my right portion, I just equal to n by 2 and then I is less than n and then I plus. Now if the character count dot find for that specific character, which is S of I, if that is equals to my character count dot find that specific dot end, if it's equal to end, which means I was not even able to find that character, or character count of that specific character, which is S of I, if that is equal to a 0, then for sure my answer is a false. So I'll say my possibility is a false and you can simply go and break. Now if my possibility is a false, which means for all the queries, no matter what, for all the queries my answer will be a false. For all the queries my answer will be a false. So what I'll do is I'll make my answer as, and just saying that this answer should be of length, let's name it my Q size, QZ, QSQ, QZ is the query size, queries dot size. So I'll just say make the answer for the QZ size and initialized everything with a false. It's a boolean thing which I have to return, and then simply return that answer itself. Return the answer. Now this is a base case which we can handle. Again, not necessarily you need to handle that. You can handle that in the cases condition also. Now comes the actual answer which we have to make. But for that, you remembered we have to do some pre-computation. Pre-computation as in pre-computation of the frequency array. If you remember, now that frequency array need to be of both left and right. So I'll just make it for the left. Same, it should have n by 2 characters, and for every of the index I should be having 26 characters, and by default the frequency is initialized to 0. And the same I need to do it for the right, which is the F2. Saying the frequency is F1 is the frequency prefix sum array for the left, F2 is the frequency of the prefix sum array for the right. Now, when this entire portion is done, you have to do the prefix computation. So I'll go on, but for that you need, for the prefix computation, you need to go and check for the I+1. So what we will do is, for the base 0, we will just say for s of I minus a, just do a plus plus. That's done. It's not I, it's actually a 0. Now I'll go on to my index 1 onwards to I is less than n by 2 and then I plus plus. Now when this portion is there, so I'll just do one thing, that f of I comma that for all the characters I have to go. So I have to go for all the characters in this. One way is I go into all the characters and copy. Else other way is that I can just simply go and copy f of I minus 1. It is f of 1, right? Copying the exact same thing of the previous thing, and f of 1 of I, current I, s of I minus a, s of I minus a. Now it just can be increased to the new character count, and the same thing I'll do for f2 of 0. Again, you remember that I will reverse my f2, but indexing is still 0 based. So 0 is saying it is a 0 based indexing, but I am reversing. I will go in reverse in f2. Again, remember the fact, right? Remember the fact that I have to reverse the f2. I have to reverse the string 2. So I'll reverse that and then paste it up here. So what I'll do is I'll simply reverse my s2. So I need to grab the last index value, which is s of n minus 1 minus a, and then plus plus. Grabbing the last index value. Now when this portion is done, I can simply go on from the very end, which is from int I equals to n minus 2, I is greater than equal to I is greater than n by 2, I is greater than equal to n by 2, and then I minus minus. So I'm just simply trying to go in from the left part, and that's it. Like just simply the left part, and then simply get the answer for the left part. Can be a tricky case that f2 needs to be handled from the left. So for this current index I, which is okay, I should go in the indexing of 1 based. So next should be the 1 index. Next should be the 1 index. Like again, I will modify this, but next should be the 1 index corresponding to this specific index. Modify the value, which means f2 of 0. F2 of 0 you will get, and then f2 of 1 for that specific index, which is s of I, right? S of I minus a. You will simply increase the count. So start from the 0, then 1. As you will go, but you will see it's an I index. You have to get the 1. How you will get it? Simply, as simple as that. You know that you have to get the 1. So n minus 1 is that value minus of I. N minus 1 minus 5 will give you that specific value, which is the f1 1 here, and for sure 0 is nothing but minus 1. So n minus 1 minus I minus 1. Just simply add a minus 1 here, and again f of 1, simply I just replace that with n minus 1 minus I. Now this entire portion is done. I have got my prefix sum computation done for f1 and f2. Done. Now exact, this is done for, okay, let's name it as prefix sum computation of left string and right string. Prefix sum computation of the left and the right string. Now when this portion is done, so now next what we will do is we have to go and also do a prefix. Oh, it's for all the characters, for all 26 characters, right? And then also you remember I had to do prefix sum computation of exact match, which is 0 for equal and 1 for not equal. You have to do. Now when we will do this entire same stuff, what we can simply do is that we can keep track of an array of same prefix sum, saying the array will be what was the name which we had given, equal prefix sum, let's say. Obviously, like not equal pref sum. It's an array which we will make. Again, that array we can just make of size n by 2. Initialize the by default value is 0. Just think that I'll compare the I and IA. If I do a vector, keep on correcting if anything I did wrong. Now, what again? Let's go a bit. Let's have a bit space. Okay. So now we will just go and have to go in the left part, in the entire left part. So for int I is equals to 0, I is less than n by 2, and then I plus plus. Now I have to compare that if that cut is equal or not, but you have to have that thing answer not equal pref sum for that index 0 should be equals to that my s of 0. If that is not equals to my s of n minus 1, then it's actually a not equal prefix sum. So I can start off with index 1 itself. As simple as that. Now from s of 1, I'll just compare if s of 1 is not equals to, firstly I can simply go and say not equal prefix sum of I. It's exactly matching, it's exactly like as we do a rollover. So we'll just simply do a rollover of I minus 1. I'll just simply do a rollover value. If this s of n minus 1 minus I, if this is not matching, then not equal of pref sum of that specific I increase by 1. Right? Okay. I can just simply put this in the one line itself. Now I just do I've just simply assigned that value and then simply added, if it is not same, then simply added a 1. Now comes the interesting part, which is the answer for us. So I'll just again, if you guys are liking it or have any doubts, you can just simply comment down below. I'll just make a answer vector of query size. So query size, and initialize all that. Okay, it's a bool vector. Initialized every one of them by default as true. Initialized by default by as true. I'll go on to all of my queries. So auto q in queries. I'll go on to all of my queries. Now in the queries itself, as you remembered that it's a vector. So I need to get my L1 R1 right, corresponding as in the code I showed, L1 R1. So L1 will be q of 0, int R1 will be a q of 1, int R1 will be a q of 1, q of 1. Okay, q of 1. Then L2, you will say it will be a q of 2, right? And you will say R2 will be a q of 3. You will say this. Is it right or wrong? Firstly, tell me this. Is it right or wrong? Is it right or wrong? Tell me. Write down below. It's right or wrong? No, it is not. Because you remembered that my question was saying my range as, if you remembered, my question will say range as 3 to 5. Right? I am converting this to the entire reverse part. I'll firstly reverse this and make it as a 0, 1, 2. Remember that part, right? So this should come as left, but as a 0. So I say L will be n minus 1 minus this value R2, which is actually q of 3. As you remembered, q of 3 is R2, which you are assigning, right? But it is n1 minus 1 minus q3. This will be n1 minus 1 minus q2. That is the actual value of L2 and R2. So I'll do the same thing, exact same thing. That I'll say it will be n minus 1 minus q2. It will be n minus 1 minus q3. That's how you can simply get this solved. Now, okay, you have grabbed L1, R1, L2, R2. Now comes the interesting part, that You will first check, I'll just do my gradual checks. As you remember, my first check was for this fixed portion, for this fixed, which are actually strict. So first we check, okay, we check for fixed left. Now left is nothing but, as you remembered, left is nothing but minimum of L1 R1. It is from 0 to minimum of L1 or L1 L2. And again, when I say L1 L2, while computing the prefix sum, it is actually saying that, okay, less than that it should be there, minus, because you remember -1 we do, I am saying L1 L2, but I want from there, from this remaining portion is actually L2 -1, right? So you can just do L1 L2 minimum and then -1. You have to do so as to get this value, because prefix sum is stored in that value itself. So it is minimum of this value -1, which is the left part which we are checking, and the same which we will do, exact same stuff for the right part. So the second check which we will do is we check for fixed right part, which is again nothing but maximum of R1 comma R2. Again, please remember that you have to do a +1 to get the value up till the super end. Now super end, as you remembered, that super end is n2, n by 2 -1, because I'm just considering only the 0 to n by 2 wali range, and everything is indexing based. So to check this portion, I will just simply go and firstly check if that is actually my more than 0. So only if it is more than 0, then it's actually valid to check. I'll just check minimum of L1 L2 -1, or like -1 not required, because I just want to check if it's actually also like I just want to check -1 is more than equal to 0. More than equal to 0. That's what I'm wanting to say. If it should be more than equal to 0, right? That is a case which we want to consider, that minimum of L1 L2 -1 should be more than equal to 0, and also this not equal prefix sum, because it should be exactly matching. So I'm just using this not equal prefix sum of this minimum of L1 L2 -1, right? -1. If this is more than 0, so my possibility of the answer is actually false. So what I can do is I can make a new variable, or I can simply assign this answer for that specific QZ as answer of this QZ. Oh bro, sorry bro, it's actually a false. The same, we will write the same condition for my right, saying that what about the max of R1 comma R2, and then it should be R1 comma R2 +1 should be actually less than equal to n by 2. That is a case which we need to handle, that it should be equal, and also not equal prefix sum. For what prefix sum? Prefix sum starting from like n by 2 -1, because that is the index, because for the range of 0 to n by 2, the indexing is 0 to n by 2 -1, minus for this value, which is maximum of R1 comma R2 +1, right? +1. This should be more than 0. So this entire thing should be more than 0. If it is, again, which means it is not exactly matching. If it's not exactly matching, simply return a false. Now the case 2 is done. Now we'll come on to case 3. So case 3 is nothing but we just check for the frequencies of both the ranges in the left and the right. So we will find, as you remembered, we have to go and start off with these 4 cases, if else and if else, right? Now for this if cases, we have to go and find this v1 v2 also, v1 and v2. This is, we will compute parallelly, but this is what you have to find, v1 and v2. So what we will do is find the v1 and v2 V1 is the frequency of characters in range L1 comma R1, and same for V2. It is the frequency of characters in range. Again, is everything okay in live stream? Okay. Yep. No one told that bit shifted. Cool. So what we will do is, everything is okay, right? Yep. So what we will do is, now we will have to, okay, my hand shifts my laptop. Now I'll just shift a bit more if it's okay. This is okay. Now we will frequency of characters in the range same L2 to R2. Now when this portion we have to go and find out, so we can just make a new vector, new vector named as v1 with having 26 characters as the frequency, and v1 is nothing but the frequency of characters, right? So I know that I have to go and find the frequency of the range f again R1 to L1, and this prefix computation I've done already. This will help me to get this frequency in this range. So I want nothing but f1 of R1 plus R1 minus f1 of L1 minus 1. That's what I want. That is what I want ultimately. But if you remember, this is a vector of 26 alphabets. So this can't be done directly, but ultimately I want this, something like this. So what I will do is, I will firstly have to assign my f1 with R1. Then I will have a quick check that if my L1 minus 1, if this is more than equal to my 0, right? If this is more than equal to 0, then I can actually go and subtract with this value, else it won't be even possible to do that. So just simply do one thing, that do a subtraction. So subtraction, I will go on to all of my 26 characters, but use all of my 26 characters, which is from index 0 to index 26, but you saw that it will be a repetition for multiple times because you have to just subtract the changes, right? So let's subtract character at index. I'll say at R1 you do with the L1 minus 1 you do. So I'm just making this new function saying subtract characters at the index. It will just do a simple subtraction. So I'll just make this function which will return void subtract it. It will have two vectors. Both the vectors can be passed with simple address values because I want to do in place I want to do this specific subtraction. So I'll say that I will have a vector v1, right, and I will have another vector again passing by address vector v1. I have another vector which is the next range. So let's name it as a R, let's name it as a L. So I need to do the subtraction of characters at the index, and maybe I could have returned the specific vector itself, which is a new vector which I would have made, but I can do a in place in this R itself. So what I'll do is I'll go on to all of my 26 characters less than 26 and I plus plus. I'll just say that R of that specific index I just do a subtraction with this L. Now this subtraction entire portion is done. I have just done a simple subtraction so as to get the values. So this entire portion is giving me this value. Now what I will do is that I have my L1, I have subtraction done. The same I will go and do for L2 or V2. v2. Again, I actually wanted to do a, if you remembered, I wanted to do a f2 of r2, although I actually wanted to do a f2 of r2 minus f2 of l2 minus 1. L2 minus 1. So I'll just again go check L2 minus 1 should be greater than or equal to 0. If that is the case, then do a subtraction at the index, which is R2, and do a L2 minus 1. Now, my current, for this current query, my V2 and my V2 and L2, sorry, my V1, my V1 and V2 are ready. Now, when my V1 and V2 are ready, now I can just try for those two if else conditions. If else conditions. Now, what we mean by those if else condition is those 4 cases. 4 cases to consider overlapping. To consider overlapping. Now, simply what I will do is simply go and check that what overlapping is being done and what overlapping we are doing. So simple, that we will have a condition that if my L1, again, it's the, if I just go and show you exact same conditions, if else conditions, if my L1 is less than L2, get this frequency, subtract this frequency from V1, right? I'll do the same thing, that if my L1 is less than my L2, else says my L2 is less than equal to my L1. If this is the case, simply if L1 is less than L2, then simply go and remove. Again, if you forgot, then you got the characters from string 2. Again, let me write, get frequency, get f2 L1 L2. Again, that f2 L1 L2 is this thing, and remember that this range is actually a minimum of these values. So get this, or let's write the same thing, that f2 L1, and this thing is the minimum value. So f2 L1 and then minimum of L2 minus 1 comma R1. Get the f2 which is from string 2, and then subtract from S1's frequency array of range L1 to R1, which is V1, right? I don't want to go into next character, so I'll just write this as V1. So ultimately saying do a V1, like you can just make a new array itself altogether, but ultimately you want to do a V1 is equals to V1 minus this value, which is f2 of L1 comma minimum of L2 minus 1 comma R1. So with this you will actually be like able to grab this specific value and subtract that. Now would be the interesting part, that how will you do this, which means L2 minus 1 R1. So you will grab this now of L1, so you have to grab, okay, it's a f2, you have to go and check the f2 for this also, which means I have to go and say for this L1 to this entire range. So if I want to go and get for this entire range, I was saying this L2 minus 1 is for this, right? Starting from this value. Now for this entire range I want, up till L1 I want, right? So I will be subtracting with L1 minus 1. So this will be L1 minus 1. I will be subtracting my entire range from, which is the f2 range. So this entire thing, now I just wanted the f2 value for this specific range, right? F2 value for this specific range. So this f2 value for this specific range, L1 comma minimum of L2 minus 1 comma R1, which means the frequency of given range is nothing but saying it is f2 of, because you remember na, f2 is just this array, specific array. F2 is just having just one value for the specific index. So f2 is nothing but f2 of this specific minimum of L2 minus 1 comma R1, subtracting it with f2 of L1 minus 1. Now when you have grabbed the specific f2, now you can go and you can come and subtract this value in from v1, right? So I'll just go and do the exact same stuff. That firstly I have to grab this value, so let's name it as a vector of int of f2, or I'll say f2 left, or like I'll say f2 first part, f2 subtraction first part, which is nothing but f2 of minimum of L2 minus 1 comma R1. That is the f2's first part, which is the minimum value, L2 minus 1 comma R1. And then I'll go and have to check that L1 minus 1 should be greater than or equal to 0. If that is the case, then f2 first can be subtracted with a value of f2. Now we have done and made the function of subtraction, so I'll just copy the subtraction function from f2 first. I'll subtract a value which is f2 of L1 minus 1. Now when this portion is done, I have got this entire f2 value. I've got this entire f2 value in f2 first. Now I can just simply go and subtract from my v1. So I again go and call this function subtraction from v1, subtract my f2 first value, and that would be great. Now the exact same stuff should be done for the f1. So I just say f1 first. It will be my f1 of minimum, exact same stuff, f1 first, f1 of minimum of L1 minus 1 comma R2, right? And then checking that if my L2, or basically L2, you should have done if it's a v1 of this values, you're doing a L1 minus 1, so here you do a L2 minus 1. So L2 minus 1 should be greater than or equal to 0. If simply L2 minus 1 should be greater than or equal to 0, then you can just simply subtract your f1 first, FIRST, with this values of f1 of L2 minus 1. Now simply subtract your v2 from this f1 first. Now again, this entire thing is done. Do the exact same stuff for R. Exact same stuff you have to do for R itself. How? That again, R1 is less than R2. So again, you will just go and do some stuff. If we go back and check what you have to do, simply when R1 is less than R2, grab this value which is f1 of R1 comma R2. So I will have to grab f1 of R1 comma R2 and subtract from v2, right? Again, get this value, subtract from v2. Now this R1 can be, this R1 actually will be nothing but this should be this R1 plus 1 to R2. So R1 plus 1 to R2, and this should be R1 plus 1 to like R1 plus 1 of L2. So it is actually saying that my f1 is R1 plus 1 to R2, and then I'm actually saying that f1 is actually nothing but maximum of R1 plus 1 comma L2 to actually a R2. That is the value which I wanted. Now this can easily compute it as f1 of R2. Now this value is actually nothing but saying f1 of R2 minus f1 of Simply if it's f1 of r2 minus f1 of this values, which is this specific value, you want the range sum, right? You want the range sum minus 1 will be the specific range sum from this to this. This to this will be the range sum represented by this. Now again the same stuff we will write, vector int same. I want what? And again subtract this entire stuff from v2, which means do a v2 minus of f1 of r1 comma r2. Now I just want the f1, I'll say f1 first, name it anything whatsoever you want. I just want f1 first, which will be f1 of r2. Now I'm just simply going and asking that if this max value, if it is more than equal to 1, so more than equal to 0, so max of r1 plus 1 comma l2, max of 1 comma l2, what is this? Max of, oh, this is what is this? This should be like this, yeah. Oh sorry, this should be like this, max of this value minus 1. If this is more than equal to my 0, then I'll say that f1 first, sorry, subtract, sorry, control shift C, what was subtract from index, get the f1 first, subtract with this value of f1, subtract with this value of f1, this specific value which we have taken, and this entire thing we will take off and do it, subtraction of control shift C, this value, sorry, what I did, f1 of control Z, sorry, f1 of, I'll write max of r1 plus 1 or l2, the maximum value which I have taken, minus 1 should be the previous place which I have to get, minus 1 is the previous place which I have to get, and with this I'll get the answer. Last part is subtract, okay, subtract from my v2 this value of f1 first, subtract that, and the same you have to go and do for your this, when your r2 is less than equal to your r1, exact same stuff. Let's write it down, int of f2 first, saying that it will be f2 of r1, right? Exact same stuff, f2 of r1, this exact value which you have taken here, it will be simply L1, no, it will be R2 plus 1 and L1 minus 1, R2 plus 1 comma L1 minus 1 should be more than equal to 0. If that is the case, then I'll do a subtraction of this value f2 first, subtract with this value which is f2 of this value which is max of r2 plus 1 comma L1 minus 1. Okay, when this is done, now simply do a subtraction from v1, with this value of f2 first. Now subtraction portion is luckily done. Now let's come on back to checking. Okay, subtraction portion. Now this portion subtraction is entirely done. This is entirely done. Now compare this white portion. So what I'll do is I'll simply compare the white portion or the overlapping portion or the completely overlapping portion. Now just have to compare this entire white portion. So just have a bool flag initialized by true, Now go on to our all the characters. For 0 to less than 26 and I++. Now this V1 and V2 should match, which means V1 and V2 should match for frequencies, for frequency of characters. Now frequency of characters. Now what we'll do is simply have a simple subtraction that we'll just simply do V1 of, let's say, this I subtracted with V2 of I. Now at any point of time, if we are doing this subtraction at any point of time, if it becomes negative and all that stuff, we are done. Obviously we are screwed up. That is simply we have to go and check that if I am going and doing a subtraction, if like it's just a subtraction of these values, both can be negative, positive, all that stuff. If I'm just simply, if V1 is, let's say, we can have multiple cases. V1 of I is, let's say, 2 and V2 of I is, let's say, 5, then for sure we have a -3. If it's same, it will be a 0. If any other value, then it's a false case. So V1 of I, if it is not equal to a 0, then my flag is actually a false. Flag is actually a false. False, by Ligja false, false. I simply say that for that specific answer of specific index. Oh, I also need to have the index, right? Answer of QZ is not false. Answer of index should be false. So I will have to maintain the index, indexing starting from 0. I'll say ID in the last, I will do ID plus plus. ID plus plus. So what I'll do is and say that for this specific ID, answer of this specific ID is actually 0. So QZ is replaced by ID. Okay, QZ is not ID. Answer, yeah. Now I'll say that my answer of ID is actually a flag. That's it. And simply return. So let's remove this entire part, and here we can simply return the answer. Now let's see if it's actually line 73. Line 73. This is a value and this is a value. What's the issue in this? Not equals to what it says that for, oh sorry, 73, line 73. We have a if condition. If condition would have been there. Now let's quickly go and compile. Okay, subtract index R1 L reference value vector of int. Okay, R1 subtract. Okay, line 4. Okay, R L. Okay, line 79 line. If it's R1, oh, R1 is a value. We have the index. Got it. So it is V1. It's a V1. It's a V2. Because it's a V2 minus this value, which is F2 of L2 minus 1. Should be like this. Should be F1 of L1 minus 1. This like any other thing which you guys are thinking that it's incorrect or should have been there, like, because I think that there can be multiple wrong things. Oh, great. runtime error. Now it's more harder to figure out where the runtime error is, but it should be very obvious location. It's an integer overflow, which means it's a indexing overflow. For sure, it's an indexing overflow which we are having. How to know that part? We have checked indexes. It's just that we have to recap where we have not checked the indexes, or maybe you can just try commenting things down. That's the only obvious thing. Shortest way to check where we're getting runtime error. Okay, runtime error is not here. Okay, great. I don't think here it should be. R2 F1 of R2, all are the indexes which you have taken care of. Oh, let's comment this portion and see. I just want to figure out which portion has the runtime. Oh, it is this portion only. Okay, got it. If we comment this portion, then is it this portion which is giving runtime error? Oh, it's the top portion, which is this portion. It is giving us the runtime error. Great. So F2 first, it is the minimum of these two values. I should take the maximum instead, because although we have to take the minimum, but both of them, L2 minus 1 and R1, whatsoever is minimum, and L1 minus 1 should be more than 0. If I just remove this, this right here, remove it. Was it because of this else condition? Yes, this else condition. That F1 you're grabbing, it's L1 minus 1 or R2, so it's minimum of L1 minus 1 or R2, and then if L2 minus 1 is more than 0 or equal to 0, I'm just referring that go and do a F1 of L2 minus 1 and then subtract my V2 from this value of first. How L1, which line is giving this line? No, which line then? This line, vector of int F1 of this line, L1 minus 1, but I'm saying L1 is more than. Okay, if I just F1 can also be initialized to a smaller value. So if I say F1 is R. Anything whatsoever you guys think. Hey, hello crazy algorithm. How you got so good at explaining, brother? It's just that with getting the logic itself and all that stuff, not much big. Alight, hi, Alight. My laptop is still shifted. Yep. Okay. Okay. And Thrice. Hi, anyone know any good resources for Angular? Okay, Walt. Hey, hello, crazy algorithms. Cool. Now we're just figuring out that why we are getting this runtime error in this huge complex code. And okay, let's go step by step. So firstly, I forgot. Okay, That was the issue that I realized, that it should have been n1 minus 1 with the specific ID itself. But am I saying that still this is an issue? Still this is an issue? Yes, still this is an issue, bro. What's an issue in this? You just got the first f1 first value. Okay, let's go. How we made our v1 via f1? How we made our f1? F1 we made previously. F1 and f2 we have made previously of size n, which will have all the indexes. Sorry, from 0 to n by 2, 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 n minus 1, 0 to n by 2. Yeah, that's correct. Not equal thing is also made correctly. Okay, that's also correct. Now I got my L1, R1, L2 and R2. L1, as you can see, that it's Q of Q0, Q1, N1 minus 1 minus Q3, N1 minus 1 minus Q2 is R2. When this portion is done, my first check is if my minimum of this values of L1 and L2. If this is, so answer is false. L1, L2, yeah, that is true. Minimum of these two values, L1 and L2. I am referring this line, exact this line. So minimum of L1 and L2 minus 1. We're just figuring out that where we can have runtime error. So that's propagating downwards. And the same I'll refer for maximum. It should be less than n by 2, n by 2 minus 1. And the same for plus, less than. If it's more than 0, then again it's a false. Okay, now we get v1. v1 is nothing but f1 of r1, and L1 minus 1 is more than or equal to 0. I'll subtract v1 of f1 of L1 minus 1. Same for v2. I'll do again. If you guys can comment down below anything which you think of is actually impacting the answer, would be great. Or any typo which you might think I might have done. F2 is F2 comma R2, and this is L2 L2 minus 1, and that's also equal to 0, so I can just do L2 minus 1 also. Now comes the cases. L1 is less than L2. I grabbed my minimum of L2 minus 1 comma R1, L2 minus 1 comma R1, and then F2 of L1 minus 1 with this value, considering L1 minus 1 is more than 0. And the same goes for subtracting from V1, where I want to subtract from V1 ultimately. And oh, what if both are equal? Then, okay, both are equal, then L2 is less than L1, and if both are equal, then I'm just handling that condition priorly. Okay, R2 is less than, let's see. Okay. It might. Fingers crossed. Wrong answer. Okay. Okay. So let's if L1 is less than L2, then I'll grab my L2 minus 1 and R1. L2 minus 1 R1 subtracting with F2 of L1 minus 1. F2 of L1 minus 1, that's true. F2 of L1 minus 1, that's true. And now I'm checking for L2 is less than L1. Same. F1 first will be L1 minus 1 minus R2. And same for L2 minus 1 more than or equal to 0. So L2 minus 1 subtracting with F1 first. Now we do V2 of V2 comma F1 first. So will that thing make sense? I'm referring that. Got it. So here you saw that 0 to 5 is this portion. My output is true, and 10 to 14. Hey, okay, if I just copy this entire thing in my notes, just copy it here. Okay, it cannot be copied, but yeah, copy it to clipboard. let's write this as ODAX. I've got the thing. What is the issue? Just comment down below what do you think is the issue. Again, if you are actually thinking of parallelly with the example itself, UASUOEUTXWA 0 1 2 3 4 5 6 9 10 11 12 13 14 15 16 17 18 19 and is 20. So I will just land onto a 10 and that is here. So I'm saying that this portion 0 to 5 can be changed, and 10 to 14 can be changed. 10 to 14. Okay. So I'll show you. So this is the example which they have taken. So this is the portion which they can change, and this is the portion which they can change. Again, if I just reverse this down according to my entire stuff which I have made, so it will become AWXDUEOUSA, and indexing is 0 1 2 3 4 5 6 7 8 and 9. This is starting from E going up till A. This is the portion which we can change, right? Okay, cool. Now so what this problem would have done was it would have just saw this portion, tried to make it equal and subtracted the frequencies. So A has gone, okay, A has gone, W has gone, W is not there, so W is actually -1. W's frequencies will have been -1 here. E is there, yeah, E is there, E is gone, yeah, U is there, yeah, U is there, U is gone. Okay, cool. Now this entire portion, it will go and try to subtract from here itself. Okay, A is gone, yeah, A is gone, W is gone, W is not there, so W is -1. X is gone, yeah, X is gone, D is gone, yeah, D is gone, U is gone, yeah, U is gone. Okay, and yeah, and then it will go and try to say that for the portion which is actually having us in line with us, so can we any way try to make the frequencies as same or not. So you will see the frequency of O, S, O and S are same, and W's frequency is also same. One very big fault which we have done, the frequency is should have been not here. So the possible thing which they could have done is bring O, it's OS, make it exactly equal. This can be rearranged, this can be rearranged, this can be rearranged, this can be rearranged. Okay, so like yeah, it's obvious that my W is actually having -1 and it's matching with the frequencies, and thus I will not be able to actually say that it's like the difference is actually a 0. So because of this also, it will be just simply saying it's actually true. So I can try to have a one more condition check, that if my I is 0 less than 26, I plus plus. Now if anyone v1 of I is less than 0, right? Or my v2 of I, if it's actually less than 0, then bro, sorry, it's a false. It's a false. And else I can go also here and we'll check if this is true. Then if it's matching, then it's a false. Now let's go and check this if it passes or not. Because it's just that the frequency would have been negative and then it should have matched. Yeah. Don't give wrong answer. Great. Now what's one thing which we are missing? So if the frequency is false, we're just placing it as a false, so we would be handling that. That's one more case. And my flag is false, so I'm not assigning my answer until the entire answer is done. Did we return from here? Did we return? Okay, we did not. So here we did not return from here. So I should have continued from here itself. Maybe I'm guessing this could have populated my answer back. Sorry, not break, continue. Well, I'm guessing that this could result in a answer which is continue, because like if it's a false here and then I assign in bottom, I assign that as a true and then I assign that as a true, so that can be a wrong answer. So let's see this, if it passes. That's the reason, like this case is kind of problem which actually makes it hard. Like, okay, this is working, let's check. Okay, again a wrong answer. Now it's a true, but my answer is a false true. Now what could have been the case? So I'm just persistently doing a false, which is the answer should have been true, but I am putting a false, which means I'm putting a false because of some of this condition itself. Let's see. So I'm saying that if the flag is false, then the answer is a false. If it's not assigning, so if I just plot this exact same down here and I just say it's a B, C, E, C, D, 0, 1, 2, 3, 4, 5, 6, 7, and that's a bifurcation, D, C, A, 0, 1, 2, 3, and it just says from 3 to 3, 3 to 3, and from 5 to 5, 5 to 5, okay, 5 to 5. So I'll just show, this is the condition which they are saying, that 5 to 5, they should match, and I'm returning the output as true, while the answer should have been a false. So which means my flag, oh, here I should check if my v1 of I is not equals to v2 of I, because negative I've already checked, so I don't need to check this, I can check this only. Let's compile this, and true and true, false and true. Okay, again it's still wrong. So in this, all these 26 characters, I'm just going and checking if the frequency doesn't match. I'm screwed up. So flag is false. Here also, if any of the frequencies are less, so again the flag is false. What could have been the issue? I'm returning a true. So here in this case, I'm returning a true, which means I'm just having this condition. This I'm going and checking. Okay, I'll just go and check this. This I'm going and checking. And this portion I'll say and check technically. So this is a E, this is actually a A, this is a E, this is actually a C. So for sure the frequency should not match. Here also it's not matching though. So here also it's not matching. A D. So which means my issue is on the top. It's not assigning the value, proper value. Okay. Makes sense. It should have gone here only. Right. Non-prefix sum of these values. So it should have assigned my Q1, Q2's values, and then it should have gone down. Which means my not equal to prefix sum, if firstly I assign that I minus 1 value and then doing the fourth question. Yes, correct, Shubham. Nowadays Leetcode contest difficulties are very unbalanced. IMO. That's true. It's just that we are stuck in some cases trying to figure out which case we might have missed, just so that to get the answer completed. No worries, we will be doing it. No worries at all. So yeah, not equals to for that prefix sum. If the size is n by 2, now I'm going on to all. I'm firstly going on to my first element and saying if that is not equal, it's a 1. Okay. That's true. It's a 1. Simply assign the I minus 1th value, the current value, else assign a 0. Okay, that's true. And then simply say I to n minus 1 minus I, which is I to n minus 1 minus I, then simply add corresponding to this index of 1. Okay, my non-equal prefix sum is correct. Then I'll come on and check for those values, which means L1, L2, minus 1. If this whosoever is minimum in this, minus 1, if this is more than 0, so answer corresponding to that. You saw what happened? You saw. I was using ID here, then I was initializing my ID here. It is the reason. Shit. Okay, ID plus. Yaar, that's the reason. Like, this big code is hard to visualize always. If it false true, false, true false, true. I commit suicide now. Cool. We have messed things up, but no worries at all. No worries at all. Now let's see कहाँ पे दिक्कत है. It is a 4489. So 1 2 0 1 2 3 4. Okay. And output is a true. The count is also itself not equal. Okay. The base condition should also have been wrong, right? So possibilities are false. Here itself it should have returned this. It returned a true. here itself, because you see na, count is not even same for left and right. It would have returned false. It did not. Let's see in here. I do a character of count. You saw what's the mistake here. I'm not even doing the character count. Okay, character count of that s of I minus minus. Wallah. Okay. Please, God, please don't do any mistake now. Fuck. That was cases. So you saw, you have to just handle all these cases and get the answer. That's it. I know that no one would have stayed. For the ones who have stayed also, their laptop is on and they would have slept. But school, no worries. If you have any doubts, please don't ask me. Kidding. You can just comment down below. And yeah, that is the code which you can have. Again, that's a very big code, so I'll paste the submission link. Now, how to go to submissions, I don't know. So I can go to the discuss, then I can go to my solution, and then I can go to my submission, and then I can go to this accepted link, and then I can just paste that link for you guys, because it's a very big code, so you can get lost, right? This is a submission link. Cool. Yeah, and if you can please smash that like, baby, that would be super great. That will be super great. And yeah, we'll be ending the stream. It has been how many? Oh, it has been 3 hours. It has been 3 hours. We have been doing this stream for 3 hours. It's 2:55. It's 3 o'clock. Oh no. Cool, but no worries. This was a very hard, not hard, but cases. That's the reason you can see the number of submissions are lot. User tried, accepted are less, because cases questions. Cool. Thank you so much for watching. Bye TTU. See you, tata, goodbye. Any doubts you can just comment later also in the video. I'll be very happy to answer them. Yep. Cool. Bye. यार थोड़ा प्यार दिखा देना जान से पहले यार. बाय.